Yes, sir.
Okay, thank you, Shahari. So today I'm going to discuss about the processing part, right? So yesterday, or sorry, the last week, you learned about the agronomic practices of tea, rubber, and coconut, right? So I completed myself the rubber part, and Sagar sir completed the uh, tea agronomy and also the coconut, right? So today I am going to cover the processing aspects or the processing techniques of tea and rubber, right? Okay, so I'm going to start with tea because last time you ended up with the tea agronomy. So I'm going to start with tea processing, and thereafter I will be conducting the lecture on rubber processing. So that is how it's going to happen. And after this session, Sagar sir will continue with the coconut processing, right? Okay. So, if you have any questions regarding the lecture or anything that you don't know during my session, you can raise your hand from this Zoom platform, or otherwise you can interrupt me. Not always, right? But if there is something that you need to clarify, then definitely you can ask at the point, right? Okay. So the other thing is, if you are not receiving my voice, or if you can't see my slides that I'm sharing, just let me know, right? Because sometimes, because we don't know, we are dealing with online platforms, so there might be some technical issues in both ends, in my end also from your end. So you can just ask, so I can't see the slide. Then it is a common thing. Then definitely no, the fault is from my end. So I will check into the connection and do the corrective things. So let me know, just right, if you can't hear the voice clearly or you are experiencing any lags, right? Okay. Without taking much time, we'll start the session. I will put
Recording
the.
in progress.
Okay. So last time you completed the agronomic part, but not the harvesting part of tea, right? So you know how to grow it. Can you see my slides?
Yes,
Yes,
sir.
sir.
Okay, okay, thank you. So last time you learned about the agronomic practices. What is the tea plant and where it comes from, and how to grow, and what are the planting materials, and how we keep the nursery. Those things you have learned, right? So today you are going to learn about the harvesting and processing of different types, mainly both types, that is the CTC and black tea manufacturing. These things I'm going to cover, and there are some other processing methods as well. So I'm going to introduce these things, but I'm not going to explain them in deep, right? For your level of knowledge for this diploma course, it is enough to know the basics, right? Okay. So first of all, you have to know the basics. So I will skip some slides of this presentation if it is not, or if it is too deep to your subject. I mean, for this diploma course, but I will share the slides so you can read further, you can learn more, and if there is anything to know further, you can ask questions, right? Okay, now you know how to grow and all the agronomic practices. Hereafter, I am going to explain about the harvesting, right? Because the first thing is taking out the tea leaf from the tea bush, right? Otherwise, we can't carry out the process. So, harvesting techniques means you have to take out the vegetative portion, right? Here, we are not taking any rubber and tea, both are in the same way, because when we are talking about coconut, we have to harvest the fruit, right? Coconut, right? But here we are taking the vegetative part, the tip of the plant, tea plant, right? In rubber, it is rubber latex, right? So what we are going to do about, I mean, the harvesting part or the harvesting practice that we are using in the tea, we call it as plucking, right? So what is plucking? The process of harvesting the tender apical portion of the shoots by selective hand picking is called plucking, right? So plucking means you are selecting the top portion or the tender apical portion. Tender means, what do you mean by tender? The soft, right? the softer portion, right? It should be soft, not the hard part, right? Soft portion, the apical part, the top portion by hand picking, right? We are doing it manually. Now we have different machines introduced, but still it is very difficult to identify selectively. That means some of the leaves are not in the correct stand, or they are sometimes very hard, not tender, right? So we have to select it. That is why we are practicing the manual picking. Now, the shoots are plucked at regular intervals throughout the year, 4 to 10 days intervals, right? So if we pick tips or the apical part of the tea plant today, so we are going to repeat the practice after 4 days or 5 days, right? According to the climatic conditions and the availability of the uh, tea leaves, right? Because sometimes, according to the nutrient facts, climatic conditions, the clone we are using, the range or the ability to grow, right? The rate of growing the leaves might change. That is why we are saying, according to the tea stand, so we are going to decide whether it is 4 or 5 or 6 or until 10 days intervals, right? The plucking is one of the most important cultural operation in the tea cultivation, which has great influence on cost of production, quality of made tea, vigor and physiology of tea plant, right? So cost of production, I will discuss these things. So first one is cost of production. Plucking is the most labor intensive and the most expensive field operation in plantation. If you know these operations, if you are from any area where you can see tea plantations, you can see how the laborers work at tea plantation, right? They are always with the tea bushes, they are plucking, right? So, what we have to always engage human facts or human effort in the tea plantation for this plugging practice. So, it is the most expensive field operation because we have to do it manually. We don't have any vastly used mechanized system, right? So, we have to expend more. So, that is why it is very costly, right? It absorbs 30 to 40% of requirement of labor on these estates. So you can see 50 to 60 of the cost of field operation. Now you can see how the cost of production occurs, right? So we are adding cost of production, and when we are selling the, the uh, whatever the final produce, black tea or CTC, whatever the tea, the most of the cost of production from the final product acquired by the field operations, right? And field operations, highest portion is going for the labor or the plucking, right? So labor requirement is 10 to 12 pluckers per day per hectare. So you can understand the situation, right? Per hectare, we need 10 to 12 pluckers, right? Plucker means the person who is hand picking the apical portion, right? Okay, the quality of made tea. The quality of made tea is mainly depend on the quality of shoots that are harvested and supplied to the factory. So to ensure the quality, we have to manually pick. That is why I always mention that we have to select the correct tender leaves. Otherwise, we can't obtain the correct aroma or the desired aroma what we are expecting. අපි හිතන අපිට අවශ්‍ය වෙන තේකේ තියෙන රස සුවඳ අපිට ගන්න බැරුව යනවා. Therefore, it is important to pick only the good quality shoots, avoiding coarse leaves. Coarse leaves mean the leaves that are hard, right? And whatever the stem parts, right? There are some stem parts because it is very hard, so it is not tender. So we call it as coarse leaves. Care should be taken to avoid unnecessary delay in sending the plug shoot to the factory in good condition, right? So we are not crushing, we are not pressing, so we are not applying any pressure to that tea leaves. So we have to maintain the tenderness until it reaches the factory, right? Maintain leaf standards. There are some leaf standards. Leaf standard means number of leaf standards divided by number of leaf standard price, number of sub leaf standard, substandard leaves, right? So no need to buy hard these things. This is for your own knowledge. I'm not going to ask any questions, but you have to know there are some standard leaves and substandard leaves. So I will show you some pictures, then you can identify, right? So what is standard leaf? Standard leaf is but with one, two, or three leaves, right? Normally the standard or the accepted amount is three leaves and but it should be tender, not coarse, right? So, but with one, two, or three leaves. Tender benji shoots. I will show you what are benji shoots. Then tender single leaves. These are the standard leaves, right? Then there are another category called substandard leaves. All the pluckers they know whether this is standard leaf or substandard leaf, but with four or five leaves. So it is substandard. So you can understand, right? Standard is the most preferred and most accepted high quality portion. But for the amount that, because when we are plucking only few amount of leaf, that means it will reduce the final produce. So we have to maintain higher amount of production, because high production also give higher profits. But adding more and more leaves, I mean more and more coarse leaves, will reduce the quality. So we have to maintain the quality as well. So we have to think in two different aspects. While keeping the quality, we have to increase the production. That is why we are calling standard leaves and substandard leaves. So, but with four of more leaves, cause benji shoots, cause single leaves, shoots with hard stalk, damaged leaves. Those are the substandard leaves, right? For your understanding. No need to buy that. So here you can see at the center, those are the tips and three leaves, right? One or two. So here, this is the most standards, right? The most preferred standard is, or the high quality standard is here. See, right? It is very tender, fresh, so you can produce very high in quality tea. But still, you can use these leaves as well, right? Here you can see these leaves as well. So they are the look at these leaves, right? You can see it is kind of harder than these leaves, right? So that means it is coarse leaves. Still, it is not harder. Oh, it is not. It is not. How do you call it? Still, you can use it for the processing, right? Still you can see the color of the leaves, but you can see it is hard, but it is not the hardest one. Look at this tea bush here. These are the very coarse leaves, so you can't use these leaves, right? So if you use more of these leaves, that means the final output or the quality of the final produce or the tea will reduce. So the market value for that tea will get decreased, right? So we need to have a good market demand. That means we have to take the measures to keep the leaf standard, right? Okay, higher proportion of bench shoots adversely affect both quality and productivity, right? Bench shoots, what are the bench shoots? So I will show you. Therefore, to maintain the quality of the tea, high standard of plucking is extremely important, as I mentioned. So the third one is vigor and physiology of tea. First, we discuss the cost of production. So plucking is very important for the cost of production, quality of made tea, and the third one, vigor and physiology of the tea plant. Vigor means how it withstand or how the plant is surviving, right? Plucking is a destructive operation where tender apical shoots are continuously removed. We are always remove the apical part. That means the tea bush is always trying to get taller, but we are not allowing it. We are always plucking the top part, right? අපි උඩ තියෙන කෑල්ල අයින් කරනවා. So it is not good. Always we are stressing that plant. So that bush can die. නේ? ඒකට හැම වෙලාවෙම stress එකක් දෙනකොට it will reduce its vigor. So we have to maintain the good plucking practices to avoid or to minimize the stress to the plant. When a shoot is plucked, the axillary bud then uh, the axillary bud is activated and develop into new shoots. You always know when we pluck or when we cut down the top part, it will again divide into two, or it will branch out and it will produce new shoots, right? It will happen again and again, it will happen. But when we are doing so, we have to make sure that we are not stressing or we are not giving very harsh conditions to the tea plants, right? Growth of shoots. The shoot growth is basically influenced by plant factors, soil and climatic factors, biological factors, right? So there are different factors. So when we are talking about plant factors, the physiology of tea plant, there are different clones, so they are giving different types of um, shoots, right? The cultivar, right? Uh, and age in the pruning cycle. So we are doing a practice called pruning. I think you already did you know about the pruning last time? Sagar sir discussed it. Pruning. Anybody?
Yes, sir.
Do, yes or no?
Yes.
Yes. Okay. So you know how to prune, right? So age in the pruning cycle also matters for this final shoot. So soil and climatic factors also matters, and biological factors like pest and diseases. The three major consideration in plucking. Okay, so what are the three major considerations? Standard of plucking, severity of plucking, and frequency of plucking. So we have to think about the standard. As I mentioned, there are standard leaves, substandard leaves. So we have to decide from the tea plantation whether we are going to continue with standard tea plucking or with the substandard also, because we have to decide to produce more production or to increase the produce or keep the quality in high, or we can move in between like a spectrum, right? අපිට high quality ම තියාගෙන අපිට අඩු production එකක් කරගෙන ඒකේ authentic අර aroma එක තියාගෙන ඉන්නවද? එහෙම නැත්නම් තව චුට්ටක් අපි cost leaves චුට්ටක් add කරලා production එක චුට්ටක් වැඩි කරන ගමන් quality එක maintain කරනවා. So it depends on the decisions made by the plantation, right? This refers to the composition of standard flush leaf of the harvested crop, right? So standard or the acceptable flush or leaf, we call it a shoot with two tender leaves and bud, right? So it consists with the bud and the leaves, right? The apical portion. Then shoot with three tender leaves and bud. Sometimes the third leaf is not tender enough, right? Sometimes it may be a coarse leaf. So we have to check. That is why we are doing the hand picking. So the plucker need to observe the tea bush. They are doing it very quickly. We can't observe that because they have the skill and the practice, right? So when they are touching the tea bush and the apical part, they can identify whether it is a coarse leaf or tenderly. So we have to think about that also. Then immature or dormant shoots, right? Unexpectable flushes are the immature shoots, right? If we pluck the immature shoots, that means we are losing the harvest because we have to keep that part until it grows. Then it will give higher produce, and the plucker can pick it in the next round, right? So we are not plucking all the tender parts. That means we are calling it generation of plucking. So you are not going to learn it here, but we have to maintain the sustainability, right? Because when we are plucking today, all the tender parts are removed. That means you will not have anything to harvest in your next round. So you have to keep the tender shoots until it grows, right? But you can, the desired level of part, I mean, one bud and two tender leaves or three tender leaves and bud can be plucked, right? So standard of plucking, the fine plucking means more than 75% of the standard flush. So standard flush means two tender leaves and bud or three tender leaves and bud, right? Plucking coarse leaves will lead the drop in quality of made tea. I already discussed. Then severity of plucking, the plucking style. This refers to the point at which a shoot is plucked, right? Where we select or the where we going to start plucking, right? The place, right? The appropriate plucking style should be selected depending on the prevailing weather pattern, right? So we have to think about whether it's a rainy season or dry spell. So we have to think about all the climatic conditions before we commencing the plucking, right? Bush vigor and labor availability. Sometimes you can't frequently pluck because let's say, as you see, we need 10 to 12 labors per hectare, right? But if we have only 5 or 6 labors, we can't do it round, I mean, frequent, right? So we have to go for a, I mean, let's say earlier it was done by 5 days interval. Now we have to increase that 5 days into 8 days because we don't have enough labor. So when we are doing so, that means always the tea plant is growing, right? Tea plant is growing means we can observe more coarse leaves, right? මොකද වෙන්නේ අර tender leaves උනත් ආයෙත් තව ඒවා තද වෙනවා. So we have to make sure that we are plucking the tender parts. But when we are doing so and when we are delaying the plucking table or plucking cycle, that means the tea bush growing up and the plucking table will increase. Plucking table means uh, the the level that we are maintaining to pluck. අපි හිටගෙන ඉන්නකොට අපිට අතින් අල්ලන්න පුළුවන් ප්‍රමාණයට තියෙන උස තමයි ප්ලකින් ටේබල් එක කියන්නේ. So මොකද වෙන්නේ? අපි තේදළු නිලන ප්‍රමාණය කියන්නේ නැත්තම් කාල සීමාව වැඩි වෙනකොට මොකද වෙන්නේ? ඒ තේ දැල්ල තව උඩට උඩ හැදිලා ඒව ඝන වෙනවා. එතකොට තව tender leaves එනවා. හැබැයි අපේ table එක ඉක්මනින්ම උඩට යනවා. So we have to maintain. That is why sometimes we are plucking coarse leaves as well. So it will reduce the quality, right? දෙපැත්තම හිතන්න ඕනේ. Severity of plucking. Light plucking, single leaf plucking, mother leaf plucking, right? So those are the severity plucking, right? Then point of plucking, just above the first mature leaf. So we actually we can't identify just observing, but with the practice, you know where to pluck. Type of leaves left on the bush: one mature leaf, fish leaf, and scale leaves, right? Those things must be avoided plucking, right? So you can see here, the top part is the active bud and 2 leaves. You can see, right? So here 3 leaves and bud. Here you can use plucking, right? The red one, red arrow. I think you can see my okay. Here you can start plucking. This is the foliage, right? Foliage leaf. And here also you can use another one, or you can include another leaf for your standard, and you can pluck here. But you have to avoid the fish leaf. You can see this type of leaves in the stem, right? මෙන්න මේ වගේ පොඩි leaves. So you have to avoid the fish leaf, right? Then these are the scale leaves. Scale leaves are there, so you have to avoid the fish leaf, right? This is single leaf plucking, the red arrow, and fish leaf plucking means from the point is near the fish leaf, right? Okay. If you don't understand anything, just ask. A well-planned plucking policy with a combination of light and hard plucking during the different seasons by maintaining a good canopy depth could be carried out, right? That is how you can do the plucking. Then frequency of plucking. Plucking round is the number of days between successive plucking. The plucking round varies from 4 to 10 days. It depends on the jet, age, and elevation. So these things I'm not going to discuss for your own understanding. It is more than for the stage. So shorter rounds generally result in higher yield than longer rounds, right? Haphazard extended plucking, right? Rounds may not only lower the made tea quality but also reduce the yield, right? So if we delay the plucking round, it will reduce the yield also, right? Extend rounds may influence the plucking standards due to high percentage of over mature shoots. As I discussed, when we are delaying the plucking, it will, I mean, this is a plant, right? It is a living thing, so it will grow, continuously grow. Tender leaves eventually get coarse, right? It will get hard. So we have to pluck these things. That means, again, the percentage of over mature leaf shoots in this harvest will increase. Then other important aspects of plucking. Plucking table should be even at even and should follow the slope of the land, right? The plucking table, right? Plucking table, as I mentioned, the plucking table, right? Okay. මෙන්න මෙහෙම ඔන්න ඔය විදිහට අපි එක විදිහට තියෙනවා, right? So this is the plucking table. So it should be even. මේ මැද්දෙන් ඔහොම ඉතුරු වෙන්න බෑ කැලේ. Right? It should be even. So we have to maintain the plucking table and follow the slope of the land. So you have the experience in tea estates. They are in a very beautiful slopes, right? So it align with the slope of the mountain, right? This should initiate from the time of pruning, tipping, and continued with the bush creep. Bush creep, I will show. So this is the leveling stick. After pruning, when leaves are growing, we have to maintain the plucking table. So the coarse leaves higher than this plucking table should be plucked and removed, right? We are not taking it to the harvest, but we have to maintain the table. That is why we have a leveling stick. So two T blocks, they are leveling by using this stick. So this is how they practice the plugging. I think some of you may have the experience who are coming from the areas where the tea are available, right? So anybody has the experience of plugging? මෙතන කාටර experience එක තියෙනවද plugging එකට? Just tell me anybody who is from the area of tea plantations. No. Okay. This is how they maintain the plucking table. So it should align with the slope of the land. And you can see this light green color shoots. Those are the tender leaves. So you can pluck these leaves and you have to avoid these dark green color leaves. They are coarse leaves, right? So easily you can identify. So here you can see it is aligned with the slope of the land, right? Just like the mountain, it is always aligned with the slope. It's very beautiful scenery. See how the drains are made and how the walking paths are there, right? See? And here you can see, sorry, removal of Banjo crossfeed, Banjan crossfeed, or Mudichi. We call it as Mudichi. Should be a routine practice. After plucking, it will remain some of the sticks without leaves, right? Because we are plucking out the leaves and it will remain some sticks. So we have to remove these sticks, otherwise we can't maintain the plucking table and it is not facilitating the room for new shoots, right? These are Mudichi. Mudichi කියලා කියන්නේ මොනවද? Benji and Mudichi, right? See, after plugging, we have to remove these parts. These are the scale leaves. These are the scale leaves. See, we call it as crow's feet, like the feet of the crow. කාකෙක්ගේ කකුල වගේ නේ. So this is how we are removing mudichi. We can't manually hand pick. We have to use a knife, right? Because it is very hard. Then it allows new shoots to grow. When we are removing mudichi, it will allow new shoots to grow. Here you can see two leaves and bud. It is very tender and ready to pick. Here you can see the scale leaf. So you can pluck above the scale leaf, right? Immature shoots. Arimbus. We call it as arimbus or arimbus. Right? You can hear it as arimbus. Must be left unplugged to be taken at the next round as heavier units, right? As I mentioned. Coarse leaves and stalks should be removed in the field to maintain a better leaf standard than plucking table height, right? Same thing. Shoots on side branches and hollows on the plucking table should be left unplugged until they cover the open spaces. So sometimes you can observe open spaces because the patch is not grown well and we have to maintain the plucking table. So we are not plucking that area, right? Just seeing that there's a tender leaves and bud and tender leaves, we are not practicing the plucking. If that part should be grow more, right? To maintain the table. Pluckers should be instructed not to ram the flush into their baskets, right? That means we have to use different types of basket and we are not pressing it, right? It should be, we have to maintain the tenderness. If it crush it, that means the processing starts on the states. We have to avoid that. Pluckers should be instructed not to retain an excessive number of plucked shoots in their hands, because always, if you see this practice, you can see some videos in the YouTube also. They are not putting the whatever the things they plucked one by one. They are just keeping something in the hand, and after keeping some, I mean, the amount, it will throw to the bag. If the plucker keep more than the amount that she can keep in the hand, that means it will again crush the leaves. That means it will start the processing the hand. So we have to avoid that. Plucking on the rested bushes and the lungs of prone bushes should be avoided, right? Plucking on the rested bushes. Sometimes we have to think about the vigor of the plant, right? So some bushes we are deciding these plants should be grow more. Still, it has. I mean, we are not giving the stress by plucking. So we have to, especially for prune bushes, right? After pruning, we have to allow some time for its growth. After pruning, that means seems we are seeing some what do you call hard part, only the stem part and small shoots coming out. So we have to allow these shoots to grow. Otherwise, if we continually remove these shoots, that means it doesn't have time to grow, right? If it not grows well, that means again we are reducing the amount or the final product, right? Possible damages to plug shoots at the point of weighing, bulking, and transporting should be minimized. There are different types of bags. Or not now, we are not using bags actually. There are some plastic containers. You can stack one one on another, but yeah, it is not crushing the leaves. But if we use bags, that means again we are crushing the tea leaves in the transportation, right? So we have to avoid. So this is how they are taking do the cultural or the agronomic practices and how the um, pluckers get paid, right? See, these are the different types of tea collecting bags or the bags where the pluckers put their tea leaves, right? Different types, right? Now we are not using these goni type ones. Different baskets are there. This is how they practice the weighing, right? Each and every plucker bring whatever the amount that they pluck from the state to the collecting point or the weighing point and weigh, and according to the weight of the tea leaves, the payment or the wages are allocated, right? Education of pluckers and careful supervision on plucking will ensure the quality of made tea, right? Then mechanical harvesting. Mechanical harvesting should be sought if hand plucking is impractical due to scarcity of labor. Mechanical plucking, there are different two types, plucking shears and plucking machines. We practice these things when there is a labor issue, right? Labor scarcity. So this is a plucking shear. You can see we can pluck few of the, I mean, easily by using this shear plucker. Sometimes we are using that one. And here you can see the basket or the back, the pack the plucker used. It is a different form, right? So you can see it doesn't crush the leaves, and how uh, this person is used the shear plucker for the practice, right? So this is the shear plucker. And this is the plucking machine. So to operate this plucking machine, we need 2 to 3 people, and the power supply mostly it is battery operated because we can't use any power cables. We have to move here and there in the state, and it is difficult to use cables. So it is also a unselected uh, harvesting, right? So you can't select whether it is 10 or course, whatever the top part will cut off and collect it to back. So the quality of the made tea will reduce, right? This is another machine. So you can see how it goes through the top part of the tea bush and how it removes the top part, right? So this is how they maintain the. Now you already saw the tea lands in Sri Lanka, and here this is not in Sri Lanka. So you can see there are some rows or ridges to operate this machine, right? So the tea bush is maintained according to the width of the machine, right? Disadvantages of mechanical plucking: no selectivity, right? So that means the quality will reduce. Higher proportion of cut leaves and coarse leaves, damage to the maintenance foliage. Mechanical plucking cannot be completely replaced hand plucking due to terrain shade trees, right? There are shade trees, so we have to avoid shade trees. Uh, uh, Shade trees, right? Okay. Okay, that's all about the plucking part, right? So I will share this slide presentation so you can read more. And if you have any questions, you can ask now. Then I'm going to start. Any questions from the plucking? Okay, now we are going to start the black tea manufacturing process. There are three different types, so we are going to learn about the black tea manufacturing. So I will explain these things. Before that, give me 2 minutes.
Recording stopped.
Okay, so now you know how to harvest, right? Can you see my slides?
Yes, sir.
Okay, so there are three different types of processing, mainly black tea, right? That the tea that we are regularly consuming. So regularly we are using black tea that is fully fermented. And there is another tea called oolong tea, semi-fermented, and unfermented tea that is green tea, right? So I think you have heard these names. So we are going to learn about the black tea manufacturing first, right? So black tea manufacturing also, there are different types, three different types. The most famous or the mostly practiced one is Orthodox Rotavian tea, right? Orthodox Rotavian means upcountry tea manufacturing. Then pure Orthodox, that is low country manufacturing, and CTC, cut tea and curl method. So there are three different methods of black tea manufacturing, right? Okay. So quality of made tea depend on the external appearance, right? We have to think about the quality of made tea before we commence our processing practice, right? Because the ultimate goal of this practice or ultimate goal of processing tea is to give high quality tea cup, right? So the external appearances are the color, clearness, size and shape of the particles. When we are looking at the made tea, we sometimes we feel the size and the shape. So these are the external appearances. Then cup characters. What are the cup characters? The color of the made tea cup, right? Then the flavor. We need to think about the flavor, whether it is a strong one, mild one, light one. Likewise, we have to think about its flavor. Then the strength, whether it's a strong tea or a light tea. Then the pungency, right? All these things are in the cup character, and the external appearance and the cup characters define the final quality of the made tea, right? chemical composition of tea leaves. In the tea leaf, there are different types of chemicals: polyphenols, caffeine, amino acids, carbohydrates, right? These things are the factors affect for the quality of the made tea. The polyphenol oxidase enzyme is also present, right? There's a very important enzyme called polyphenol oxidase. However, in fresh leaves, enzymes are physically separated from polyphenols, right? Physically separated means, yeah, here you can see. This is a cross section of a tea leaf. So you can see the epidermal cell layer here, right? At the top, it is epidermal cell layer. So you can see the presence of polyphenol oxidase at the epidermal cell layer. Then there is palisade cell layer. That is the middle part, right? So polyphenols are there. Normally, you know, if you followed the biostream, you know anything that oxidates, any enzyme that oxidize any substance, we call it from the same name, right? So the enzyme that has the ability to oxidize the polyphenol, we call it as polyphenol oxidase. Then you can understand what happens when polyphenol oxidase contact with polyphenols, right? Then at the before the bottom part, we can see the mesophyll cells, again the cover part or the epidermal cell layer. So that is the cross section of the tea leaves. So with the presence of polyphenol oxidase, look at this equation. Polyphenols can convert, or after the reaction with the polyphenol oxidase, it will break the polyphenol into thiaflavins and thiarubigines, right? So remember it, right? This is the basic, what do you call it? The basic principle we are using in the tea processing, right? That is how the green leaf turn into the black color, right? So when we are crushing it, these polyphenol oxidase contact with polyphenol and it will divide, or it will break down polyphenols into thiaflavins and thiarubigines, right? Okay. These are the black tea manufacturing steps. You have to know these things, right? Withering. First one is withering, then rolling, roll breaking. The fourth one is fermentation or the oxidation. We are giving some time for that reaction, right? Then firing or drying. That means we are arresting the fermenting process, right? We are stopping. We are manually stopping that process. Then sifting and grading, where we take out the doubles and where we separate the different particles, right? Then the last one is packing. Okay. What is withering? Reduction of moisture to achieve rolling process without any wastage, right? Reduction of moisture to achieve rolling process. We will discuss what is rolling without any wastage. This is the first step in black tea manufacturing. Large number of chemical and physical changes occurs during withering process. Normally withering means we remove the moisture, right? We allow some time. We are having different methods to remove the moisture, excess moisture. Normally, when we are crushing a leaf, we can observe the moisture, right? අපි අතට කොලයක් අරගෙන හොඳට අතින් පොඩි කරලා දුවන්නේ. ඒක නේ වතුර වතුර යවනවා. So here, what we are doing, we are reducing, or we are allowing it to evaporate the excess moisture, right? Then there is the first withering is physical withering. The most obvious change during withering is loss of moisture in the leaf. This is called physical withering. This will help to reduce leakage during rolling process, right? Leakage means, rolling means it is crushing the leaf, right? So if you are crushing very moist leaf, that means it will ooze out what? Water, right? Water is substance. So it will cause some leakages. It will create some pulp. So we don't need any pulp, right? We need to just crush it and take some particles, right? Not the sludge, right? Then the chemical withering. There are a lot of chemical changes occurring the withering process. This is called chemical withering. The physical withering means whatever the things that we can observe from the outside. That means it will reduce the moisture and it will we can observe it, right? The chemical withering means chemically change, right? Among these chemical changes, important changes are increase in caffeine, right? The caffeine is the most important fact in the cup, right? According to the caffeine content, the quality of the teacup uh, differs, right? Then increase in amino acid, increase in flavor compounds, and increase in cell wall permeability. Cell wall permeability is important because if it is not permeable enough at the crushing point or the rolling process, it will not contact or the polyphenol oxidase will not contact with the polyphenols because we have to reduce the cell wall permeability. There is a cell wall, right? So we have to reduce that permeability. Minimum of 6 hour duration is required for desirable chemical changes. Normally, withering time is 6 to 10 hours according to the climatic factors, the trough that we are using. Likewise, we have to allow it to that much of time to do this chemical and physical withering. The optimum condition required in the withered tea leaf depends on types of roller that used in rolling process. So there are different rollers. First one is orthodox roller, right? So in the processing there are orthodox rolling and CTC, right? Two of the processing we use orthodox roller. CTC is something else. So orthodox roller required hard withered leaves, right? So we have to remove much of the moisture. Withered leaf should be rubbery condition to facilitate breaking of leaf into flakes without wastage of tea juices, right? So we have to avoid tea juices. We don't need any tea juice, just we need only flakes, right? That is why we are removing most of the moisture. But in the CTC rollers, tea leaf need to be lightly withered to avoid breaking of tea leaves into flakes. In CTC rolling, we don't need flakes. We need some juices there, right? Because ultimate goal is to have some dust. CTC made tea we used in tea bags, right? අපි ගන්න තේ බෑග් වල තියෙන්නේ මොනවද? ඔන්න ඔය CTC manufactured. ඒක අපිට flakes නෙමෙයි දකින්න පුළුවන් චූටි චූටි කුඩු, right? So that is how we made tea bags. Withering can be done in two ways: natural withering and artificial withering, right? There are two artificial withering systems, TAT system and trough system. Natural withering can't be done because we have to allow it to dry. We don't have that much of spaces because it is an intensive processing method, right? Day by day, we are making thousands of kilograms of made tea. So we don't have enough space. So we have to condense it and we have to do it very quickly. If we are doing natural withering, it will affect by the climatic condition. If it is a rainy day, definitely we can't observe or we can't fulfill our practice, right? So we have to go for the artificial withering. In artificial withering, there are two systems, TAT system and trough system, right? ළමයි ඔයාලට මොනවද තේරෙන්නේ නැත්නම් අහන්න සිංහලෙන් වුණත් කමක් නැහැ මම මේ කියාගෙන යනවා මම හිතනවා ඔයාලට තේරෙනවා කියලා. Am I too fast? Just give me a comment. Am I too fast or is it okay to understand?
Okay.
Okay. Thank you very much. If you don't understand or if I'm too fast, just let me know. I will explain it again, right? Because you have to know these principles very clearly, right? Not from peripherally. So you have to know it very clearly. If you can't understand these things, what are the flavins, their origins, and how it happens, just let me know. I will explain it again, right? Okay.
Excuse me, sir.
Then
Can you explain the TAT system and the trough system?
Yes, now I'm going to explain these things, right? This is TAT system. TATs are made of jute hessian. Jute hessians or synthetic netting, right? There are some nets, they are synthetic, right? TATs are arranged 15 to 20 centimeter apart from horizontal layers. So first one is jute hessian TAT. Efficiency of withering is very low. Spreading rate is 0.5 kilogram of green leaves per square meter, right? Within 1 square meter, you can spread only 0.5. That means 500 grams, right? Synthetic TAT spreading rate is 1 kilogram, right? Green leaf per square meter. So this is the TAT, right? This is the TAT. So there are different layers separated. So you can see the netting in these squares. In these nets, you can arrange the tea leaves and allow it to wither or allow it to reduce the moisture. So the space between two TATs are 15 to 20 centimeters. you can see the practice normal. Now we are now not using this system because all the things are mechanized and we are using only trough system because this is inefficient. We have to allow it to we have allow it to more time because it affect with the climatic changes, right? අපිට එළිය වහින තත්ත්වයන් නම් තියෙන්නේ මොයිස්චර් කන්ඩිෂන් එක වැඩි නම් සෑහෙන කාලයක් බලන් ඉන්න වෙනවා වේලෙන්නේ. හැබැයි ඒ වෙනකොට ආයෙත් මොකද වෙන්නේ? අර හාවස්ට් එක ඇතුළට ඇවිල්ලා තියෙනවා. හැමදාම තේදළු නෙලනවනේ කොහෙවත් එක. So we can't allow. The factory is very, I mean, comparatively with a small area. So we have to quickly dry off, right? So we can't allow it to keep longer time period because it will lag the rest of the house. ඊළඟට එන්න තියෙනවට අපි ඉඩ දෙන්න ඕන. So we are not using it. This is an old picture, but you can see how the tats are arranged, right? This is how you collect or transport the tea into the tea factory, and this is how the factories transport the tea bags through conveyor belts. This is a conveyor belt, so we have to move the tea bags into the upper part of the upper part of the tea factory. And this is a trough system, right? I will explain. This is a trough. This is not a tap, but here you can see the railings, right? There are hooks. So these tea bags are hanged in these hooks and allow it to go through these tea rails. And there are some labels they keep or they remove from the hook these bags and spread it on the troughs. So this is not a tap, it's a trough. Trough system. Long troughs are used. Right? Dimensions of trough. Width is 1.8 meter, right? So that's the preferred standard, and height is 1.05 to 1.2. Length can be adjusted according to our requirement. According to our house, we can decide the length of the trough, right? And the fan. Also, this is the trough. You can see there's a fan, right? There's a ventilator where we can provide hot air and cool air. We can decide the temperature according to its requirement. And this is the channel where the airflow happens. And from the perforated top, right? This part, these are the tea leaves, and it's perforated. So what happens through these holes? It will channel all the warm wind, right? Or the warm air through the leaves, right? So it will increase the what? The withering, right? So this is the motor, you can see, and there are levers where you can suck the air, and there is another part where we can provide the hot air and combination. This is electric fan, right? This is a trough, you can see here, right? At the far side, you can see the trough, and you can see the electric fan also, right? So by rotating this fan, it will artificially provide the wind. So it will go through or go under this trough and through the perforated plate, the air will come out, right? Advantages of trough system, right? What are the advantages? Less labor requirement, even withering, right? Why? It is evenly spreaded and the airflow coming from the bottom, and it will evenly wither, right? Space requirement is also less. Spreading and collecting operations are easy. Airflow can be used efficiently. After withering, weighing of withered leaves should be done, right? Because before transfer to the roller, leaves should be sieved to remove unwanted particles. Sometimes by collecting or from the pluckers, there might be some stalk particles, some granules or something from the flow of that estate. So all those unwanted things might be there. So we need to practice the sieving, right? We have to separate all the unwanted particles before we start crushing. When we are crushing, if there is any unwanted particle, it will reduce the final quality of the output, right? So here you can see the withered leaf. See the nature of the leaf. Now most of the moisture reduced, right? Moisture අඩු වෙලා තියෙනවා. දැන් ඔයාලා කියනවා මේක නිකන් අර කියන්නේ නිකන් තැවිලා වගේ නිකන් ඒකේ තියෙන ඔක්කොම moisture අඩු වෙලා අර තියෙන fresh ගතිය ගිහිලා තියෙනවා. So you can see here this is one of the plug tea 3 leaves and bud. So you can see now it doesn't have the moisture. That is why it is very what the nature of the leaf can be seen, right? So this is how you know, this is how you identify the correct stage of withering. So if it is correctly withered, when we take some amount of leaves into hand and crush it, right? And after removing it, right? අපි crush කරලා අතර තියලා තද කරලා අපාය නිදහස් කරාම it should be come back to the earlier stage, or not as the previous one, but it should have like a rubbery structure, right? අපි අතින් තද කරාම කැඩෙන්නේ නැහැ ඒක ආයි දිග ඇරෙනවා. So that is the correct stage where we complete withering, right? So these are the holes where we provide the withered leaves into machines, right? At the bottom there are machines. So those are the rollers, tea rollers. This is the feeder. Here we can feed, and these are the jackets, and I will show you, right? This is how you collect withered leaves, and you weigh the withered leaf before start rolling, right? Then this is the place you can see, right? See, it's a strain, right? You can see and you can remove unwanted things, and only the fresh, not fresh leaves, withered leaves channel through this hole, right? This is how you stack the withered leaves into the feeder, and you can see how. So defects in withering. So you can see uneven withering. If we can't control the airflow correctly or the temperature correctly, it will unevenly wither, right? So you can see some of the leaves are correctly withered, but some are in dark and brown in color. Brown in color means it already starts its fermenting process. That is not the good way, because fermenting happens in the next step, but already it happens. That means it will reduce the quality of the made tea. Right? See here. And some of the leaves are dried. That means over withered leaves. They are over withered leaves. Then the next process is rolling. Right? The objective of rolling process, the objective is to break up the leaf cells to mix up the chemical component of leaves with enzymes. Right? As I explained, the enzyme, where we can see the enzymes, what enzymes in the leaf? Where we can see the leaves? Give me an answer.
Middle side and leaf.
Huh? Yes. Where? At which part you can see? Now I'm going to ask some questions. You are not actively participating. Okay.
හරිත ලවවල
Huh?
හරිත ලවවල
නෑ හරිත ලවවල නෙමෙයි පුතා තියෙන්නේ. අපි portions කියවනේ epidermal cells. ඉහළම තියෙන හරිත ලව කියන්නේ සෙල් එක ඇතුලේ තියෙන එක කොටසක්.
ඉනි මෘදු ස්තරයේද?
Oh, epidermal cell. Peter the, oh yes, Peter the stare. So you have to know the English term, right? Epidermal cells, we can find the enzyme, right? Okay. Then during rolling, leaf is twisted and simultaneously broken up, right? So it's two different things happen simultaneously. We are crushing it or twisting it and breaking, right? Right? A considerable amount of heat generated due to friction during rolling process, right? Heat is generated, therefore care must be taken not to increase the temperature above 33 centigrades. What happens if temperature rises more than 33 degrees? What happens?
enzymes activation is increase.
Not. You are correct the point, but enzyme activation will arrested, right? They are proteins. So in high temperature, proteins will denature. If the protein or the structure,
ස්වාභාවිකරණය වෙනවා.
yes, when it denature, that means definitely it will arrest the chemical withering process. Sorry, chemical process, right? Or the oxidizing process of polyphenols, right? So we have to maintain under 33 degrees, right? Various types of rollers are used: orthodox roller and rotovac, right? This is the orthodox roller that I showed you in the picture. The feeder, that is orthodox roller. So these are the parts of the orthodox roller, right? So you have to know these things. Essential parts. A is the roller table, right? Roller table is there, right? Then B is the jacket. Yes, B. This is the jacket. The outer part is the jacket. Through the jacket, you can input or you can provide with their tea leaves, right? Then the central fitting. Central fitting is there. I will explain what is central fitting, right? See. Then table fittings or the battens, right? D, table fittings. E, pressure cap. E is the pressure cap. That is how you apply the pressure to crush and roll. But when you increase the pressure or when you can identify that pressure temperature is going up, we have to release this pressure and avoid it to cool. Allow it to cool, right? Then discharge door. Discharge door. And feed hopper. F is the discharge door and G is the feed hopper, right? Through the feed hopper, you can feed the withered leaf. Okay. Then these are the central fittings, right? Central fitting is the part that we can find at the center of the orthodox roller, at the bottom center, right? So we have different types: steep reti, mild reti, kegel, cylindrical, according to its shape. According to its shape, the applying pressure and how it crushes inside the orthodox roller will vary, right? අපිට ඕන විදිහට crush කරගන්න according to the grades that we required, according to the particle size, we can decide which central fitting that we are going to use. So these are the battens or the table fittings, right? We can see the crescent, right? Crescent means it has this shape, right? The slant shape, then there's a gap, again a slant fitting likewise. Then M and S, there's no gap, right? There's no gap, only the fitting. Then eaves, these are the eaves and these are the kegel, right? Okay. Roller capacity, 300 to 350 kilogram withered leaves per hour. So you can say it has a higher capacity, right? Optimum temperature range during rolling is 25 to 30. Now you know the reason, right? The temperature can be controlled by intermittent release of pressure. So you saw the pressure cap, right? The top part, the pressure cap. So you can give the 7-minute pressure and 3-minute pressure release. That means we are releasing the pressure to avoid the heat up, right? Rolling period is 30 minutes. Speed of the roller is 38 rounds per minute, right? So here you can see the table and the table fittings. Can anybody tell me what is this table fitting? මොකක්ද මේ table fitting එක? Okay, I will show you again. These are the table fittings, different types, right? Remember it. Now tell me, what is
Eaves?
this? Huh?
Eaves?
Eaves. Eaves. No. Think it in cross section, right? You can see the slant. It is very slant. Cross section, right? මේ පැත්තෙන් බලලා පැති වේලුමක් තිබුණේ. එතකොට මොකක්ද මේක? There's a slant edge and part. Then there's a gap. Again, slant part. So what is it? Yes, it is crescent, right? See, it's crescent. This is the Central fitting. So it's a cone type. You know, central fitting. This is a feeder, feed hopper. You can see how they feed the withered leaf to the jacket. This is a rotor vane, right? There are two different rollers, orthodox roller and the rotor vane, right? So this is a rotor vane. The essential parts of a rotor vane are, right? You have to remember these things in your exam, right? A is the barrel. You can see the outer cover is the barrel. I will show you a real photograph. Then B is the feed worm. Where's B? This is a feed worm, right? Spiral one, right? That's the feed worm. C is the feed hopper. The same one, right? Feed hopper, where we feed the withered leaves. D is veins. We call them as veins. E is the resistors. These are the resistors. So E is the resistors and F is the end attachment, right? There are three types of end attachment. Like the central fitting in the orthodox roller, here we can have end attachment. So it is end plate. Wait. Iris end plate, floral end plate, and conical end attachment, right? So you can see different types. The action of rotor vane on leaf is harder than that from the orthodox roller. In the orthodox roller, we are applying the pressure and releasing, so it's a smooth with the rolling process. But in the rotor vane, we crushing it very harder than it's coming from the orthodox roller, right? But it is less harsh in comparison with CTC rollers. Crush, tear, and curl. That is why we call it as CTC. So it is very hard one, right? Therefore, little difficulty of acceptance of rotor vane T in orthodox market, right? It is necessary not to lose orthodox appearance. Rotor vane should be coupled with preconditioning rollers, right? So I will tell you what is preconditioning. Preconditioning means before applying to the orthodox roller, we can pass the leaves from the rotor vane, right? So it will help to crush it, right? Then we can have the other processing part, right? If not, rotor vane will produce tea with brownish color as well as open leaf appears, right? Because the rotor vane helps to crush and tear or to break the tea particles into tea into small particles. But in the orthodox part, it's a round action, right? It's a round action, so it will not help, or it will retain most of the what do you call like shrinked leaves, not particles. කොළේම ඇකිල්ල තියෙන්න පුළුවන් particles වලට වඩා. So we do the preconditioning before the orthodox process. So this is the rotor vane. So you can see it's a small rotor vane. There are larger rotor vanes as well. So this is kind of a large rotor vane. So you can see this end attachment. It is inside this barrel, right? Barrel එක ඇතුලේ තමයි තියෙන්නේ, මේ එළියට ඇදලා තියෙන්නේ, right? This part, right? This part is inside this barrel, right? Normally, when we are feeding here, right? It is at the inside this barrel. Now it is at the outside for cleanups. Clean කරන්න අපිට එළියට ගන්න පුළුවන්, right? So you can see the parts, right? The feed worm. This is a feed worm, spiral one, and these are the veins, right? This is the hopper, right? The barrel, right? මේ තියෙන side view එක. So you can see the resistors, feed worms going through this cross. Yes. So that is how the structure looks like, right? These are the veins. You can see the shape of the veins, right? It's a feed worm. When we feeding, it is rotating, so it will crush. It will channel the withered leaves into the inside the rotovein, right? This is the end attachment, right? This is the iris end attachment. This is iris minimum and maximum. So you can see the amount of pressure that we can give, right? Iris minimum means there is lot of space. It will pass the withered leaves with the crushing and tearing off very easily from the end. But if we arrange it as iris maximum, that means we are providing much pressure and it is very difficult to pass through the end point, right? අන්තිම තැනින් එළියට එන්න අමාරු වෙනවද ලේසි වෙනවද කියන එකත් එක්ක ඇතුළේ තියෙන ප්‍රෙෂර් එක කොච්චර බ්‍රේක් වෙනවද කියන එකත් තීරණය වෙනවා. Okay, these are the veins. So you can see they are also in different angles. This vein is broken, you can see. Should be another vein. This is how it inserts into the rotovein. Resistors. These are the resistors, right? All the surfaces are what? Very, what do you call? It has different resist surfaces, right? So it will increase the cutting and threshing action. See, now it has iris minimum at arrangement, and you can see the crushed tea leaves with the tea leaves coming out and collecting to this hopper, right? Okay, here. Okay, now preconditioning of leaf. Due to action of rotovein, some of the cells would rupture, right? Then some of the enzymes as well as oxidizable matters would not be available for reaction and will remain unutilized. If the leaf is lightly rolled, a considerable twist is given with no cutting action. Then only epidermal cell layer disrupts and most of the enzymes ooze out. This type of rolling called preconditioning. As I mentioned, if we not crushed well, that means the available enzyme polyphenol oxidase in the epidermal cell layer will not contact with polyphenols. That means it will not enhance or it will not initiate the what do you call the wither sorry the fermenting action. That is why we are giving the preconditioning. Then the third one is roll breaking. After rolling, leaves are transferred into roll breaker to separate small particles, right? We call them as dools. These are the technical terms that you have to know, right? අපි තේ ගැන කතා කරලා dools මතක තියෙන්න ඕනේ. From large particles to big bulk, right? Dools are the portion that we are using for the next step. And big bulk is the remaining or unbreaked part of the withered leaves. Again, we are using that big bulk to produce dools. Again, we are passing that big bulk through the rolling process and we are taking dools out. Roll breaker consists of several set of meshes, right? Mesh means where we sieve, right? Roll breaking period is around 10 minutes. After roll breaking, big bulk is transferred to the roller again for the second rolling, right? So this is the roll breaking process. First roller, we are taking out the dools. So we are going through the roll breaker, dools coming out, big bulk, again going for the second rolling process. Again, we are doing the roll breaking. Again, we are taking out dools. Then again, big bulk pass through the third roller. Again and again, that means after one roll breaking, again we are passing to the roll breaker. Sorry, roller. The pressure that we are applying is much higher than the first time, right? Likewise, we are taking out more dools as we can. Then final big bulk, we are removing or we are using this big bulk to produce refuse tea. That is something else, right? Okay. Two types of roll breakers, rotary type and oscillatory type, right? What do you mean by rotary type? Rotary means the rotational action. Rotational means like this, right? Rotational action. Right? Oscillatory means like this, right? Or like this, right? Okay. This is the roll break. Now you can see after rolling, these are here you can see the orthodox rollers, sorry, rotoin. Then through these channels, uh, the bulk or uh, the things pass through the rotovein or the rolling process come into this sieve, right? It's a mesh, right? And there are different collecting bags, so collecting bins. So according to the mesh size, according to the size of the mesh, we can see the particle. So we are taking out the tools, and whatever the things not sieved through these meshes will collect through here. It will pass by and collect through another part here, another basket, and again it will pass through the second rolling process, right? See, you can see the smaller particles are separated and collected to bins, and harder particles still available on the mesh, and we are collecting it separately, right? Then the third one, see the color of the dool. Now it already started the fermentation process. That is why the color from green to it's kind of a brownish color, not dark brown, but it started its fermenting process, right? Because the polyphenol oxidase enzyme contact with polyphenol substances, right? Okay. Then the fermentation or the oxidation. Fermentation reaction starts as soon as leaf is damaged during rolling and roll breaking. So polyphenol, with the presence of polyphenol oxidase, break into thiaflavins and thiarubigines, right? You have to remember, right? In order to obtain correct proportion of thiaflavin and thiarubigine, leaves should be kept on tables or racks or floor some time period, which is called fermentation, right? So we have to allow it some time to complete this action and convert it the color change and the whatever the wood double or we are getting the desired aroma by allowing it to ferment, right? The quantity of thiaflavin and thiarubigine formed during fermentation depend on the period of fermentation and the temperature. High temperature will lead to rapid formation of thiarubigine, resulting in dull color liquor, right? Optimum temperature is 25 to 30 because we have to avoid the denaturing act, right? So thiaflavin to thiarubidine ratio should be 1 to 10 gives ideal liquor color, right? These are research findings. So this is the fermentation period. So you can see the quantity of thiaflavin and thiarubidine and the time, right? So thiarubidine at the time when start the fermenting process, it's very less, and you can see the rapid increase. And thiaflavin it increased at the beginning and progressively or eventually it reduces at the third half, right? So quality season a shorter period, right? 45 to 90 minutes. Other seasons a long period, 2 to 3 hours it requires for the fermentation process, right? The end point we can identify by the coppery brown color. Then the apple smell or the Easter smell, right? We call it an apple smell or this Easter smell. We can smell it and we can understand, okay, now this is the end point of the fermentation. Further fermenting process should be arrested, right? Should be avoided, right? This is how you allow it to ferment, right? There are fermenting beds, right? Tiled floors, tiled raised beds. So you can see just spreading it and allow it to ferment. See the color change happen. Color change. These are the fermenting beds. Okay. Then The last one, the firing or drying, right? Objective is arresting fermentation by destroying enzymes. Drying the tea to about 3% moisture. That means we have to reduce the moisture, otherwise it will reduce the keeping quality, right? It should be very dried product, otherwise we can't pack and transport, right? Drying is an expensive operation because it requires higher energy. Cost component of component tea drying is 30% of the total processing cost. So you can see the higher part, right? Plucking all the drying වලට කොච්චර යනවද කියන එක ගැන idea එකක් තියෙනවා, right? There are two kinds of dryers: endless chain pressure dryer or ECP dryer and the fluidized bed dryer or FBD dryers. Endless chain pressure dryer. The machine consists of 2 to 3 endless chains where perforated trays are mounted. The dowels are moved from one end to other end of the dryer while hot air is sent to them, right? It's a perforated one, so hot air coming through and we are facilitate the movement from one end to the other. Uneven spreading of dowel trays cause problems with unevenly fried dowels. Evaporation potential varies with the inlet temperature. To maintain inlet temperature at constant level, the close supervision of furnace operation therefore very essential, right? Because this drying process is very essential process. If you are not practicing it in the correct way, it will affect the final quality of the made tea. So this is the ECP dryer. This is the mechanism. So you can see the feeder and coming out dowels at the top end, and it will very slowly pass through these chains. At the end of this part, it will drop to the second layer. Again, it passes. In the meantime, hot air channels from the bottom, you can see from these red arrows, and it will evaporate. It will dries out the fermented tea, right? And finally collect the dried tea to the basket, right? So these are the endless trays, and this is the ECP dryer, right? Perforated trays are there. Exhaust temperature can fluctuate. Okay, exhaust temperature can fluctuate due to many reasons. Fluctuation in inlet temperature, variation in airflow rate, dual feed rate, dual moisture level, and dual time. No need to by heart these things, but for your easy understanding, these are the factors. I'm not going to explain, right? Residence time leaves remaining time inside the dryer as known as the residence time. Normally, the residence time is 21 minutes, right? Shorter residence time cause problems such as production of case hardened tea, right? So we have to ensure the quality, right? If we give high temperature for the easiness, because if we provide high temperature, definitely it will dry off. But quickly drying doesn't mean that we are producing high quality tea. What will happen? The moisture will retain inside the tea particle and the outer layer only dried. So it's a dried case. So we call them as case hardened tea. We can't keep this tea long period and the quality also reduce. The expected aroma and the flavor will not come out, right? Okay, I'm sorry. Then the next one is fluidized bed dryer, right? In 1973, the fluidized bed dryer was developed by Sri Lanka or the Tea Research Institute, Sri Lanka, in collaboration with CCC, the Colombo Commercial Company Private Limited, right? In the current operation also, mostly used dry is the fluidized bed dryer. Fluidization is the phenomenon created by fluid or liquid or gas on solid, that the solid behaves like a fluid, right? When dealing with fluidization of tea, the solid involvement is tea dual as a fluid is air, right? That means we provide air, right? From the bottom, you can see in this picture, we are providing air and tea particles going up and down like a fluid, right? That is why we call them as fluidized bed. So if we search for the, sorry, I don't have fluidized bed dryer. Oh, sorry. I will show you a photograph, or otherwise you can search what is fluidized bed dryer. Then the sixth operation is sifting and grading. The objectives are separation of made tea particles into various shapes and size, cleaning of grade, size reduction of oversized particles. Sometimes particles are oversized, so we have to cut them to get the desired particle size. There are three types: main grades, off grades, and fancy grades, right? So I think you already heard these things, right? Main grades are the peco, then orange peco, then broken orange peco, broken orange peco fannings, and dust number 1. These are the main grades. I think in advertisements you may heard that we are having Niyama BOPF, right? BOPFT. So BOPF is a grade, right? Not the premium one. There are different peco also there. These are leafy grades, right? According to the particle size, it will broken orange peco fannings means it is not a dust, but we can see some particles. When we take broken orange peco, that means the particle size is larger than the BOPF. Orange peco, it is more leafy. Peco also leafy. The off grades, BP, broken peco, then broken peco fannings. There's no orange, right? Then dust number 2, dust number 3, broken mixture. Those are the off grades, right? Then fancy grades, flowery grades and tippy grades, right? Only tip is harvested. Very small amount of harvest can be taken. So it will sold in, I mean, the price of the product is very high, right? Small quantity of tea tips, golden tips, silver tips may cost very high prices, right? Then flowery grades, flowery peco, flowery orange peco, flowery broken orange peco. Likewise, there are different grades. Then TP grades, silver tips and golden tips. Common sifting machine, right? Because we have to have a different machine to separate according to its particle size, right? First one is Chota rotary sifter. It consists of 5 trays. That is why we call this a Chota, right? Then Michi sifter consists of 2 trays. Then winnowing machine. Winnowing machine used to separate made tea particles according to their weight. Stalk and fiber removing machines, because we have to remove stalks. They will cause for the inferior quality made tea. So we have to remove stalks. Electrostatic stalk extractor, Middleton bubble tree stalk extractor. These are the main stalk extractors that we are having. So this is the electrostatic stalk extractor. So all the stalk particles will be extracted through this electrostatic device, right? With sthiti vidyut, right? So it will remove the stalk parts and dust or the tea particles will come out, right? No need to buy it, just for your understanding. This is stalk. This is also a stalk extractor. This cylinder is electrostatically. It has the what do you call the characteristic of electrostatic. So it will remove all the stalks and collected into a separate place, and only tea particles will pass through this machine, right? The winnowing machine, right? It gives higher, I mean, a fan gives the wind, and according to its heaviness or according to the weight of the tea particle, it will drop into different baskets. You can see different baskets, right? It පොළනවා කියන්නේ එන හුළඟේ විදියට බරේ හැටියට මේවට වෙන වෙනම collect කරනවා. This is a shorter rotary shifter. You can see 1, 2, 3, 4, and 5, right? Different sizes of measures applied in the plate, right? So what happens in the top part? It has the mesh size. What is the size of the mesh? It should be with large holes or small holes at the top tray. What do you think? The topmost
Large
tray,
hole.
huh?
Large hole.
Yes, definitely large holes. Then in the second one, it should consist with
Small.
much smaller. Yes, much smaller, but not the smallest, right? Likewise, the grading can be happen, right? This is a Michi shifter. These are the tea beans, right? You can see according to the grades, they are storing the produce of the day, right? Then they are going for the packing. This is a bulking unit. Whatever the produce go inside this container, and it can be rotated, so it will bulk, right? Different tea grades, right? This is the made tea. You can see the color, right? It's very black color. Don't look at the lady at the back and the top of the mountain, right? Just look at the made tea only, right? See the color. This is how they operate the packing. But you can see තේවල නැගලා ඉන්නේ පේනවද? අපි ඔය තමයි හදාගෙන බොන්නේ ඉතින්. Don't worry, we are fermenting it or we are applying hot water, so no need to worry about the sanitation. But now they have different practices. හරිද? මේක දැක්කට මෙහෙම නෑ හැමතැනම. සවලෙන් ගන්නෙ මේ පේනවද? Then the packing. Desirable characteristics of tea should be preserved during storage and transportation. Packing material should have high resistance against moisture penetration, right? Plywood chest or aluminium coated paper bags are used. See, this is how they pack the material. Final pack. This is the ECP dryer, and this is the endless chain pressure dryer, and this is the FBD, fluidized. This is the chamber where you can see the, where the wind coming on, and see, inside this chamber, it will dry off the fittings. This is how they stack the wood, because we need to provide hot air, so we have to maintain a boiler. So that case, we need fire, right? And this is only for your reference, right? I am not going to explain this. This is boiler room, boiler. This is how they supply the hot air. Cariniper breaker. This is one of the equipment that we can use to cut down larger particles into small particles, right? Color separator, right? Some photographs. No need to buy hat. Yeah, that's all about black tea manufacturing process, right? So now another process is there. CTC tea manufacturing. Okay, can you see my slides?
Yes, sir.
Okay. So CTC means cut tea and curl, right? The manufacturing process is much different from the orthodox or Rotovian tea manufacturing. So CTC tea ideal for production of tea bags, right? The characteristics expected in tea for tea bags are the quick brewing property, colored and strong liquor, absence of powdery dust and fiber. then grainness. If it is powder in form, we can't use it in the tea bags. Just after putting into the perforated tea bag, it will come out, right? Dust එක එළියට එනවා. So it shouldn't be like that, right? This is the CDC processing steps. As we discussed in the black tea manufacturing, the orthodox manufacturing process, here also we are using withering, preconditioning, rolling, cutting, fermentation, drying, sifting, and grading and packing, right? Okay, withering, leaves are withered on withering troughs. It requires very soft withering. 70% of moisture must be in the leaves, right? Not like the withering happens 6 to 10 hours in the orthodox rotavian manufacturing process. Here we are just removing only 30% of the moisture, right? 70% is preserving, right? Then preconditioning rolling. Before cutting the leaves into pieces, leaves must be preconditioned to facilitate uniform feeding to the CTC machine, right? 15-inch rotavian machine is used to precondition. Always you can see the rotavian machine is used for the preconditioning process. Only single passing through the rotavian machine is done. Only single passing, right? You can use 2 to 3 passing, or in the rolling and roll breaking, you observe that we can have several passings in orthodox rotavian manufacturing, but here we are having only one passing. So here you can see it's very fleshy, or it has high moisture, right? Not like in the earlier one, because it has 70% of moisture, it is very juicy, right? Then the third process is preconditioning, then third process cutting. CDC machine consists of several pairs of normally 3 to 4, right, of contra-rotating cylindrical rollers. What do you mean by contra-rotating? Contra-rotating means when you, let's say, these are the 2 rollers, right? They are touch, but I'm not going to touch here, right? So when this roller rotate to this side, this roller rotate to, this roller rotate to this side, right? Or this side, right? Same side, right? So you can see it is a contra-rotating, anti-clockwise and clockwise, right? එකක් clockwise කරගෙන අනික anti-clockwise කරගෙන. So what happened? It will increase the crushing and tearing ability of that rollers. Both rollers have serrated faces, right? Serrated faces means what? Or this side, like this, serrated, right? So it's a not smooth surface, serrated. Sorry about my drawings, but I think you can understand the point, right? Speeds of these 2 rollers differ from each other. Fast speed roller is 10 minutes faster than slow speed roller, right? So speed also differ, right? So you can see not the same way when they are touching each other. The speed, they are not actually touching. There's a small gap. Through this gap, all the tea particles coming or passing through, thereby crushing and tearing. So the speed of 2 rollers are different, right? Slow speed roller is 70 to 80 RPM, fast speed roller 700 to 800 RPM. The slow speed roller acts as the conveyor of leaf to the cutting surface, whereas the sharp edges of the fast speed roller act as the cutter, right? CTC roller dimensions, right? No need to buy hard, only for your understanding. Then tool dimensions, only for your understanding. Special care should be taken to sharpen the rollers by trained lathe operators using appropriate tools, because day by day when we are using that rollers, the surfaces might tear off, or it will fade the sharpness of the surface, right? These are the rollers. So you can see the serrated surface. These are the 2 different rollers. One acts as a conveyor coming through here, and the other one rotating fast. Then the fourth process or the step is the fermentation. Temperature plays a vital part in fermenting of teas, right? heat caused by the intense rubbing action on leaf on CTC rollers, and that generated the chemical reaction increases the temperature. As the temperature of leaf is higher than the atmosphere, air can remove the heat if the contact is efficient and air is not very humid, right? The system must, however, be able to take the heat without surface drying, right? So we have to take care the measures to avoid high heat, but the considerable amount heat should be there. CTC doubles can be fermented on a table in thin layer, usually 25 to 30 millimeter thick. So here we don't use a different place to fermentation. It's a conveyor belt, right? We are after the rolling process at the machines installed in that table, it spread uh, the crushed leaves into the conveyor. It's slowly moving. Throughout this pass, it will ferment, right? Fermentation can be carried out more conveniently in continuous fermenting unit, right? We are called them as continuous fermenting unit. The CFUs, the thickness of the tea layer is in excess of 150 millimeter, and these are supplied with the force draft of air and mechanical agitators to homogeneous and wet mass of doughs. I will tell you what these things are, right? At soft weathers, the moisture level of doughs is high and doughs can easily become lumpy. Lumpy means stacking together, right? Then this will hamper, right? Here I'm not going to explain these things one by one because it is too much for your level, but for your understanding, I'm saying these things, just know the basics, right? It's enough. This will hamper efficient supply of air to the particle surface. This problem can be addressed by aeration of doughs once or twice during the fermentation. Ball breaking just prior to the feeding, the dryer minimizes fermentation of small lumps in the air. Lumps, if present, lead to uneven dry on Katandara. This is the surface. You can see the spreader, right? This spiral is the spreader. So lumps means stacking of doughs unevenly. Through this, from the passing through this spiral spreader, it will break out the lumps and it will evenly spread to this table. See, it's evenly spread, right? And hot air is provided, right? The hot air passes. From this hot air, it will ferment, right? It will ferment through the channel, and after that, after the desired time, it will collect to this sieve. Then the drying, right? Fluidized bed dryer is very popular in CTC manufacturing. Output of the dryer will depend on the moisture removal capacity. Operating condition of fluidized bed dryer are as follows, right? No need to IR this. No need. Okay. So the basics you need is how the production happens. So I will show you some videos, right? Then you can understand. Wait. Okay, can you see this video?
Yes, sir.
Hello.
Yes, we
I hope
can.
you can see. This is okay. This is the orthodox pass, and this is the roll breaking. As we see the roll breaking, right? Rotovan pass. Sorry, orthodox rolling. See the table fittings. It is crescent type, right? This is the jacket. Jacket moving like a spiral arrangement, right? So you can see it is crushing and curling, right? That is why we are using another Rotovan pass also. See? Roll breaking. Okay. This is how when pass happens. See? These are the rotovans, and you can see how T duals coming out from the end attachment. See? These are the conveyors that feeds the duals. Okay, there are so many videos where you can observe the tea manufacturing. So watch these videos. CDC tea manufacturing. This is a different type, not in Sri Lanka, but process is same. It is the Rotovan pass. This is how fermenting happens. It's a ball breaker. Use the ball breaker. See, different type of ball breaking to bottom up, right? යට තියෙනවා උඩට ගන්න තමයි මේ වගේ machines තියෙන්නේ. See, moisture and the temperature will be measured in place. Right. It's the final product. Okay. So any questions from the tea manufacturing? Because I didn't do green tea manufacturing. I'm not going to do that part. So I'm only covering the black tea part and the CTC manufacturing. So that's enough for this grade or the diploma. So anything you need to know regarding tea manufacturing? Anybody related to this type of factory or a work environment? No. Okay, regarding rubber assignment, right? I asked you to upload it. Did you have any difficulties of uploading it?
Yes, sir. Yes.
Nobody uploaded? Is there anybody submitted the assignment?
No.
What about others?
I uploaded.
Right. Okay, what about others? Nirmal, did you upload?
Yes, sir.
Okay. So others, I think you have, now today is the 15th, right? Okay, try it again. Otherwise, I will give my email address, then you can send it to me, but I will, okay, I will give my email address. If you can't submit there, you can directly send it to me only today, right? Okay, so my email address is, I will put it in the chat box, right? Okay. Send by telling your index number and which batch, which intake, and the topic of the assignment. Otherwise, I'm receiving so many emails, so it will be neglecting. So just let me know what is the assignment, right? Okay, that's all about the tea manufacturing process.
Recording
So
stopped.
I will stop here and take a break. Now it's 10 past 10. I'm going to start the next session around 10:30 regarding the rubber manufacturing. So be here at 10:30 and have a small
Sir,
break.
I have a
Thank
question,
you.
sir.
Yes, ask.
When can we have the slides?
Slides I will upload today. Earlier slides also they are in the LMS. So definitely I will upload today or tomorrow, because tomorrow also we are having another session. After that I will upload.
Thank you, sir.
Okay, then have a small break. Can you hear me?
Yes,
Yes,
sir.
sir, we can hear you.
Okay, thank you.
Can hear you.
Now we are going to discuss. Wait, I'm going to.
Recording in progress.
Okay. Now we are going to discuss about rubber processing, right? So now you have the basic idea of tea processing and production. All the things are covered. Now the processing of rubber. As you know, our economically important part of rubber is rubber latex, right? So you know how to grow rubber and what are the climatic requirements, oil conditions, pest and diseases. So I already gave you an assignment, right? So today, here we are going to learn about the products that we can make from rubber latex, right? Okay. First, what we have to do, we have to take out the latex, right? Give me a minute. Before moving to the rubber processing, I think I have missed the harvesting part, right? I didn't cover the rubber harvesting, right? Tapping මම කරේ නෑ නේද ඔයාලට ළමයි? Did I cover this part? Harvesting of tapping, harvesting of rubber. Hello, can you hear me?
Sir.
No, okay, thank you. So the method of harvesting rubber or method of getting rubber out from the tree, we call it as tapping, right? Latex is harvested through a process of systematic wounding of the bark, right? So we are not just wounding it, it's a systematic process, right? So an ideal tapping system will give, right, the highest latex yield, lowest tapping cost, lowest tapping panel dryness, right? It's a physiological disorder, right? You have to know these things. And lowest bark consumption, because if you consume the bark very intensively, that means you don't have the bark for a long period of time, right? Because normally the expected time period is around 14 years, sorry, 24 years, right? Normally we are planning to harvest or get the yield or the latex from a rubber tree around 24 years. We can't obtain this if we are not systematically wounding the bark, right? So the latex vessels are found in the phloem tissue, right? Initiate from the vascular cambium. There is a rhythmic pattern and productive vessels are near the cambium. So you can see here, latex vessels are arranged in a concentric rings. So no need to know these things normally. Okay, so you can see this picture, right? This is the outer layer, right? At the periphery, it's a cork, right? This is a cork, the outer layer, right? So adjacent to the cork, you can see the cork cambium, then stone cells, and these are the latex cells that you can see, right? These dots, right? It's a cross section, so you can see these are the latex cells. So you can see the concentration of the latex vessels are higher near to the cambium, right? This is the cambium. But if we wound the cambium, it will produce or it will denature the reaction of the bark, right? So we have to, even though we can find most of the latex vessel near the cambium tissue, we are not wounding the cambium. So that is the critical part. That is why we need very skilled tappers. The skilled tapper has the ability to wound the nearest level by not wounding the cambium, right? So that is for your understanding. Then this is how the latex vessels are uh, aligned as concentric rings or the latex vessels, right? So this is how you need to tap, right? This is the virgin bark. This is a renewed bark. You can see the virgin bark, the tapping cut, right? So you are not wounding this part, this small amount, right? If you wound, definitely it will damage the cambium. So no need to know these things. So this is how the tapping commences, right? See, there's an angle, right? Tapping recommendation you have to know, right? How you start tapping, or when you grow the rubber tree, first you have to identify the correct stage of tapping, right? Because you can't tap just as you want, right? Tappable tree. A tree is regarded tappable only when a girth of 50 centimeter is reached at a height of 120 centimeter from the union. So now you know the union and 50 centimeter height from 120 centimeter. Normally, what is the girth increment per year in 120 centimeter height from the union? If it is a healthy tree, what is the girth increment? I already discussed these things in the previous lecture. What is the girth increment? Anybody? Per year, what is the girth increment? Hello? Can anybody tell me what is the girth increment? Ishini, are you there? Ishini, I need to check you guys whether you are available or not, because I am not happy to give my lectures to avatars, just the recordings. Ishini, are you there? Hashini Disanayaka. Hashini Disanayaka, are you there? Just tell me whether you're available or not. Prabuddha 03066. Prabuddha, are you there? Where's your badge representative? Is there anybody like that? Is there a group leader? No. Okay. Who is the badge representative? Fine. Fine. Okay, fine. So make sure that all of you are available in the classroom, I mean in the lecture, right? Otherwise it's useless of having just recordings, right? Then Vidurshini, I think. Vidurshini 03010. Are you there? Vidurshini, are you there? Met me 03009. What is this mean? You are not here now. Shehani. Shehani, are you there? So I'm just talking to just devices, right? There's nobody present. Huh? I will note down your names. Huh? Chatura.
Yes, sir.
Okay. Thank you for your response.
Thanks.
HSH Abhiratna 03130. You have to be present here. Otherwise, I will just rush through the slides and I will omit the part, right? If you are not listening, right? It's useless now. We are contributing our knowledge and time for your enhancement of education, right? For your development, your knowledge can development. But when you are not available, we can just play a record and share with you now. What is the meaning of having this type of online session? Okay, if you have any question, just ask. Otherwise, I will just pass through all the slides, right? Okay, tappable tree means a tree regarded to tappable only with the girth of 50 centimeter when reached at the 120 centimeter from the union. Then tappable clearing means 60% of the stand should be of tappable trees to commence tapping in a clearing or a holding. That means when we are taking one block, right? A block, 60% of, okay, how many trees per hectare? If it's a good stand, how many trees we can plant? What is the clearing? Not tappable, actually clearing. What is the number of trees that we can plant? It is 515 to 520 trees per hectare, right? So we have to have 60% of that more than 50 centimeter at the height of the 120 centimeter above the union. So if the girth increment is there of 60% of the trees, that means you can start tapping, right? In a tappable clearing, 45 centimeter trees can be tapped, commencing from 120 centimeters, right? After fulfilling all the requirement, 45 centimeter trees can be also taken into the tapping, right? Commencement of tapping, ideal months are November and December in each year. So height of the tapping cut. Tapping cut is done from high left to low right, right? Remember, right? High left to low right, and low end, the cut should be 120 centimeter above from the highest point of union, right? So when you are starting tapping at the first time, the lowest end of your tapping from high left to low right, the lowest point at the right should be 120 centimeter from the union, right? Slope and direction of the cut, right? 30 degrees to the horizontal sloping from high left to low right. For higher panels, it is 45 degrees to the horizontal. Higher panels means when you're tapping for a long period of time, there is no panel available at your tapping panel, and you can commence at upper levels at the last time or the last stage of the tree, right? So this is a clearing with, you can see the cover crop. Still it is not matured, right? 50 centimeter girth is not there. There's nothing to tap, right? So here this can be tapped, right? It is kind of a well established, and 50 centimeter, we don't know the measurement, but you can see now it's about to tap, right? Then marking of trees for tapping. How you mark, right? This is done for tappers to achieve correct angle, length of the cut, and bark consumption rate, right? So procedure for making it as follows. Draw vertical line on lower end side of the cut. On this vertical line, mark 120 centimeter. So you can see, I will show you some photographs. Draw vertical line on lower end side of the cut. On this vertical line, mark 120 centimeter. Determine half circumference at 2 points. How you measure the half circumferences? Half circumferences. So if this is the tree, right? First you draw a vertical line, then you measure by using a tape the girth of it, right? Then you can fold this, right? You can fold this tape into half. Then you can keep one point here and you can take the other half, other side, right? So from the other side of the tree, again, you can have another line like this. Now you can divide it to two halves, right? Place stencil at opening height, ensuring handles are vertical with the vertical and draw the guidelines, right? Extend lower guideline beyond the vertical lines, right? Then you are extending. I will show these things. Draw guidelines each year. Each year we have to draw, otherwise it will fade off, right? Like this, you can see. First, you are using this type of a stick, and you are placing a vertical line, right? Then this is how you use a tape to measure the circumferences. Take the half. The other side also you are measuring and marking another vertical line, right? This is the vertical line. Then you can see up and down half circumference. Now this is the stencil. So you are placing the handle of the stencil like this, right? Align with the vertical line, right? This is the 120 centimeter point, right? Here, this is the 120 centimeter point. So you can see, right? First 10. This is the first 10, and you can see the extended line here, and you can see, you can make half circumferences line, right? So these are the marks. Now you have a guideline to tap. This is how you correctly tap. You can see the cambium is not damaged. It is well tapped, right? So you can see how it channels. This is the sprout, and this is a collecting cup, right? Tapping quality, right? Depth. Tapping to a depth up to 1 millimeter from the cambium is recommended, right? More than that will not be allowed because it will have the potential to damage the cambium. 40% of the vessels are found in 1 millimeter adjacent to the cambium cannot be tapped, right? High yields with smooth, even uninjured renew panels are indicated of the correct depth of tapping. Then the bark consumption, right? Bark consumption per tapping excision. That means per one tapping, it removed 0.125 centimeter or 1/20th inch, right? From one tapping, right? Angale 20 එකක් තමයි අඩු වෙන්නේ. Time of tapping. Turgor pressure in latex vessels are high in early hours, and high yields could be obtained by tapping at the at that time of the day. That means early in the morning, the pressure is high, so we can commence tapping. Tapping task. In average case, it is around 275 to 300 trees for a half spiral cuts, right? Normally, we are having half spiral, quarter cuts also there. No need to worry about these things. It will change the number of cuts, stand per hectare, terrain of land, distance to aim point, the number of tapping tasks, and the tapping task will differ, right? No need these things, right? Okay, what are the main issues with current tapping method? As we discussed in the tea harvesting, here also it's a very labor intensive process. So shortage of harvesters is the main, especially the skilled harvesters, right? So it is the main disadvantage. Then use of unskilled harvesters. If they are unskilled, that means there's a potential of wound in the cambium, right? Poor quality of tapping. Low harvester productivity. High tapping cost. Low task size. Okay, so these are the main issues that we can face in the current tapping system, right? Okay, you can see the technically incorrect tapping. See, if we wounded cambium, uneven regrowth of the bark, right? So we can't tap again. Normally, we are tapping the renewed bark as well. So here we can't do it, right? So it is useless. See, like that. Okay, no need these things. No. Okay, that's about tapping. Now you know how to harvest, right? Okay, back to business. Now we can start the rubber processing. First, we have to collect the harvested latex. As you saw in those pictures, we are collecting at the initial stage the tapped latex into a latex cup, right? Utensils for latex collection. First one is spout, right? Made out of galvanized iron, and it channels latex from tapping cut to the tapping cup, right? You saw that small piece, right? We applied to the tapping panel. It channels the latex to the tapping cup. Then latex cup. Coconut shells or plastic cups are used. Normally, nowadays, we are using plastic cups. Plastic cups reduce the scrap and rare and are relatively cleaner, because when we are using coconut shells, it has a rough surface, and most of the, we can't take out the more, all of the latex. Some of them will retain in the latex cup. So it will solidify at the cup, and we have to remove it when we are tapping again. We take and we call them as අපි අර ඔට්ටපාලු කියලා කියන්නේ rubber scraps, right? So the buckets, galvanized iron buckets are used. Otherwise, it will react with the iron, right? all above utensils need to be kept clean by washing and no removal of scrap. If scrap is present when we are doing so we have to remove the scrap. Otherwise, if the scrap is available when we are tapping again, it will prone to some bacterial attacks, right? Germs will be there, so it will cause for the what do you call um, coagulation, right? Dirty cups are a source of infection leading to pre-coagulation. We are coagulating on purpose, but pre-coagulation is not need, right? So latex collection undertake after latex flow has ceased. 3 to 4 hours after first tree tap, right? After first tree tap, 3 to 4 hours, it will naturally stop. If signs of pre-coagulation, anticoagulants need to be used at the latex cup. According to the climatic conditions, sometimes if it is a hot environment, definitely we can see some clots. So we don't need any clots. Therefore, we have to use anticoagulants. There are some chemicals we can add to the cup before collect the latex. But normally what we are doing is we are not adding to the latex cup. It will be added to the collection bucket, right? Using the thumb, latex is emptied to the bucket, right? Bucket should not be kept in the sun since it can lead to fermentation, precoagulation, and appreciation of metrolactic reading. Appreciation of metrolactic reading means metrolactic reading method is the method we use to measure the dry rubber content, right? DRC content. According to the DRC content of the latex, the wages can be allocated. So if it is, precoagulation will definitely increase the density of the latex. So it will, what happen? It will appreciate the metrolactic reading. That means higher wages should be paid, but it is not in good quality because if we experience the precoagulation, we can't do the other process. So we have to avoid precoagulation. That is something we have to be careful. Preservation of latex. Before that, you have to know what are the signs of precoagulation, right? Clots in the latex cup. When you are collecting from the latex cup to the bucket, when you are pouring the latex from the cup to the bucket, you can see some clots, right? And that is precoagulation sign. Clots in latex. Sometimes you can see the clots in attached to the latex cup. Sometimes it's in the latex. Then precoagulation during transport, right? When you are transporting, it can be happen, right? Fermentation bubbles in coagulum. So you can see some bubbles coming out and formation. That means it is going to coagulate. So we have to avoid that reaction. Pre-coagulation. Non-rubbers such as proteins, lipids, sugars. I think you know the composition, right? It has dry rubber, proteins, lipids, iron, water. Likewise, the composition now you already know. These proteins, lipids, and sugar get converted into low molecular weight volatile fatty acids, right? Such as acetic and formic acid through a bacterial action, right? With the presence of bacteria, it will react. Acids due to sugars lead to precoagulation, whilst acid due to proteins and lipids stabilizes latex. So you can see the presence of bacteria, Qui-Brachydol, and oxygen reacts and produce acetic acid and formic acid. Within acidic environment, definitely latex will coagulate, right? Tapping after winter rest in wet weather and high panels lead to precoagulation. As you already know, rubber tree winters very heavily. So at some point of time in the year, it sheds all the leaves, right? It sheds all the leaves. So that is the winter rest. We are not tapping at that period. After having the flush or after having new leaves, we are starting tapping. At this point, we can see the precoagulation. Precoagulation must be stopped. For sheet and crepe rubber manufacture, short-term preservatives, that means anticoagulations, must be used. Sodium sulfide, ammonia, sodium carbonate, and are the common anticoagulates. You have to know these things. You have to remember these things. Huh? Sodium sulfide, ammonia, sodium carbonate, right? So the most common or widely used one is sodium sulfide, right? Then the transportation of latex. Now you know how to add anticoagulants to avoid the precoagulation. Now transportation should be delivered to the factory quickly to avoid premature coagulation, right? Aluminium tanks with a manhole for daily cleaning can be used. As I mentioned, cleaning is essential. If there is impurities, definitely it will react with the new latex. And what will happen? It will start coagulation. If iron tanks are used to prevent latex coming in the contact with metal, they need to be painted with inert paints, right? Inert means chemically, what do you call it? Chemically,
Akriya.
yes, it is not chemical. There is no any chemical reaction actually, right? So inert paint is a barrier. It acts as a barrier, right? Chemically neutral, right? Such as epoxy paints or bitumen-based emulsions. Bitumen means again it's a rubber-based production, right? Chlorinated rubber-based paints have the advantage of being white but are expensive, right? Cleanliness of transporting vessels is necessary to prevent contamination with bacteria, right? With the presence of bacteria, as I mentioned, Quibetrol react with oxygen, forming acetic acid, right? If so, precoagulation can set in, and crepe rubber manufacture will have streaks, right? There are two main types that are crepe rubber and RSS. So the purest crepe rubber is produced in Sri Lanka. So purest mean it is pure white. So if we see this precoagulation, that means it will cause for streaks. So it will reduce the quality of the final product. Even though precoagulation is not visible, contaminated latex can lead to discoloration of crepe rubber, right? And post collection operations. First one is preliminary training. On arrival to the factory, using a sieve fitted with monel metal. Monel metal means nickel copper alloys with excellent strength and corrosive resistance, right? Mesh with 40 mesh of 40 mesh, right? That's the size to remove lumps and bark shaving. As you know, when we start tapping or when we wound in the bark, definitely shavings must be mixed with the latex. So we have to remove these bark shavings before proceeding to the next step. Even minute quantities of copper can have toxic effect on quality of rubber, and no equipment containing copper or brass should be used. Then the weighing, right? That is also an operation that we are doing after collection. Why we need to weigh? It is the way of allocating payments for harvesters. Selling of produce, if it is latex, sometimes after collecting, they are selling the latex directly to the factories because all the estates, rubber estates, they don't have factories. Factories owned by some other planters, right? Plantation. So what they are doing, they are just collecting and selling the latex as it is, right? And for the processing also, we need to weigh. Methods. We can use metroelectric reading. It's a rapid method and laboratory method. Then DRC. We are getting the DRC. Dry rubber content. Rubber content in latex, we can measure as gram per liter or gram per gram, weight to weight, right? DRC varies with the tapping and pH, tapping intensity, stimulation, weather conditions, right? All those things can affect. Okay, first we see the Metrolec method. Metrolec measures the density of latex, right? Density of latex varies consistently with amount of rubber present, right? So the density definitely relate with the amount of rubber, right? Instrument calibrated to read the rubber content in gram per liter, right? We can measure by using the Metrolec the amount of rubber or amount of dry rubber present in a liter, right? So the method is dilute latex with pure water, 1:2 ratio. So we are taking latex, one portion, 2 portions of pure water. may not work for certain clones, incipient coagulation. Sometimes there is react with water and it will coagulate. So we can't use that type of clones for this method. Then air bubbles, froth influence the reading. So definitely we have to remove air bubbles or froth if it forms. Reading on stem from meniscus. I will show you what is meniscus. Malpractices to appreciate reading is adulterants and temperature. As I mentioned, with high temperature presence, it will increase the precoagulation and it will increase the appreciate the reading of the metrolyte, right? Adulterants means you can add some other things to increase the density, right? This is how you measure the metrolyte. See, the officers collect at the collecting point. So at the right side, the picture B shows the metrolyte reading, right? This is the way we measure the reading, right? So this is the stem, right? Stem of the metrolyte. Then the surface of the latex, right? This is the surface of the latex, right? Due to the surface tension, the latex surface will bind like this, right? So this is not the correct reading, right? This is not the correct reading, right? This is the correct reading. Okay. Then thereafter having the measurement, you can refer to the table. There's a table. So this is the metrolect reading. For example, if the metrolect reading is 90, DRC content is 280, right? Likewise, you can measure and GTT, gram per T per tapping also there. This is how you read the metrolect. There's a small video clip. I think you can see. We are allowing it to settle, right? There's no any bubbles, froth, right? See? Now you can measure. Okay, the next method is rapid laboratory method, right? Take 0.5 gram of field latex to the petri dish. I think you already know what is petri dish, right? That is the wet weight, right? So we weigh 0.5 gram of field latex. Add 2 milliliter of solution ethanol, 95% plus acetic, 5%, right? Then there are some buffer stock solutions we already prepared in the laboratory. So we add this solution and take coagulated rubber and wash with water. Now you can observe the coagulated latex because we are adding some acidic medium, right? Dry the coagulum at 70 degrees for 2 hours. Then we are using an oven to dry it for 2 hours. So it will take some time, right? It's not an instant method, but it will take some time. Obtain weight of transparent rubber part and weigh. After this coagulation and drying, you can see transparent rubber, right? So that is the dry weight. Now what is the DRC content? Dry weight divided by wet weight into 100. That's the dry rubber content, right? Okay. Now we are going to discuss about RSS, manufacturing process. Okay. Any questions from the collection of latex?
No, sir.
Then reed smoke sheet. This is one of raw rubbers commonly made in Sri Lanka, produced mainly by small and medium scale producers, right? Estates are few because they have the ability, they have the resources to produce high demanding crepe rubbers. So in home level or small scale, we can produce reed smoke sheet rubber, right? Main operations involved are coagulation of diluted latex and preparation of sheets, right? Definitely, we avoid pre-coagulation, but after getting into the factory or to the desired place, we can add coagulant to coagulate the rubber. Drying of sheets in smoke houses, right? That is why we call it as ripped smoke sheet, right? The equipment requires for RSS manufacture receptacles for coagulation. Receptacles කියන්නේ මොනවද? The basket that we can use like this trays, right? So you can pour the rubber liquid and allow it to solidify. Then machinery for rolling. Then smoke house for drying. Only 3 things needed for this process, right? Okay. First we see this is the process of RSS manufacturing. First we have to standardize, then coagulate, then milling and smoking. These are the 4 processes of RSS manufacturing. Okay. Standardization of latex. What do you mean by standardization? The dry rubber of sieved field latex, right? Remember, it's sieved field latex, right? Not just getting from the field latex. We have to sieve because we have to remove all the bark shavings and other impurities, right? Reduced to 12.5 using pure water. Normally, dry rubber, what is the dry rubber content? Average dry rubber content that we can expect from rubber latex? Yes? What is the percentage? It is 30 to 35%. Now we are reducing that dry rubber content or the DRC level up to 12.5% using pure water. 1% sodium bisulfite or meta bisulfite added to prevent enzymatic discoloration. As we know, there are some proteins. Proteins means enzymes are there. So enzymatic discoloration should be avoided at 50 grams per 100 kilograms of dry rubber, right? Then coagulation of latex. Receptacles. There are different types, right? The easiest one is pans made of either aluminium or plastic, right? Capacity is 5 liters, suitable for small scale manufacturers, right? Troughs made of either aluminium or wood. Capacity is 22.5 liters, suitable for small and medium scale manufacturers, right? Okay. The last one is tanks made of either aluminium or wood, suitable for large and medium scale manufacturers because the capacity is high. Even though a small scale farmer who is having a tank will not be essential if he doesn't have the production of 200 kilograms per day, right? Okay. Then the coagulants, right? Coagulation of latex, the coagulant. Am I correct? Yes. Formic acid is preferred. Remember, right? For RSS manufacturing, we need to have, that means for the coagulation purpose, we need to provide an acidic environment. Therefore, we are using formic acid, right? That is the preferred acid. If acetic acid is used, concentration must be doubled since it is a weak acid, right? So we have to avoid it. Commercial formic acid has a strength of 85%, right? Quantity of strong acid need to be need for coagulation of no need to buy hard. There's other figures, right? Acid is near than 1% solution and prepared by adding. Then coagulation process, pan or trough coagulation. It is different from the tank coagulation. So what we are doing, mix coagulant and latex thoroughly in suitable vessel. Tanks lined with glazed tiles, right? And distribute to the pans or trough in 6 to 7 minutes to avoid premature coagulation. That means just after you are adding or just after you are providing the acidic environment by formic acid, it will start coagulating, right? But there will be no time to allow or no time to place it properly in the trough or the pan, right? So we should do it correct, quickly. Otherwise, you will see some clots, so it is not evenly solidified, right? Also, to avoid clotting, latex can be distributed to pans prior to adding acids. So that is something practiced by farmers. What they are doing, they are adding latex only, not with the acidic acid, not with the acid. Then after leveling, after adding the required amount to the tray. The exact amount per that tray of coagulating agent is added separately, right? Pan should be stacked in a true level and covered to prevent falling of dirt. If dirt falling into that coagulating pan, that means it will cause low grade output, right? Okay. Then tank coagulation. Quantity of diluted acid is adjusted to prevent depth being more than 350 millimeter after adding of acid. Acid is poured and mixed thoroughly using a wooden or aluminium paddle. There's a paddle, right? There's a stick. We call it as paddle. To mix it well, remove froth and insert partitions at random, right? Then we have to add partitions because we have to, if it is a pan, no need to add partition. Pan size is the correct size. But if we are using troughs, definitely we have to add partitions, right? Okay. This is how coagulation process happens. See, pans are stacked together and it should be in a true level, right? Or no? Okay. Removal of froth. When you are adding when you are adding latex into the pan or the trough, it will produce froth because it already started its fermenting process. That is why it will have the acidic environment and it will coagulate. Mixing of coagulant and latex and distribution to pans produce froth and needs to be removed. Control of latex coagulation. Acids reduce pH, equalizing positive and negative charges of proteins absorbed on the rubber particles. Isoelectric points in between, just for your understanding, right? Okay. Left side or the picture B is a tank, right? Sorry. It's a trough, right? It's a trough. And right side you can see pans, right? Okay. The third process is milling. Now you added all the acidic environment and all those things. Now it's already coagulated. The next step is milling. What are the machineries we need? Hand or power operated rollers, right? Consist of smooth and marking roller. There are two different types, smooth and marking. 50 to 60 centimeter width and 9 to 11.5 centimeter diameter. Coagulum roll 2 to 3 times in smooth roller with water spray and adjust space between rollers, right? First, we have a thick coagulum, right? First pass through that, let's say like this. So if these are the rollers, earlier it has higher space in between the rollers. Now the coagulum is very thick and it passes through this and it will become thin. Then what will happen? Again, we are reducing the distance. Now again, pass through this one. It will thin again, right? Finally, pass through the marking roller. If you have the experience of RSS rubber, it has marking like a honeycomb. So that is after passing through the marking roller. Suitable for handling a crop of 100 to 200 kilograms per day. Hand or power operated rollers are for home scale production, right? Because they don't have latex yield more than that. Then batteries. How you know the batteries? Consists of 3 to 4 pairs of smooth and one spiral groove roller mounted as a unit. Because in earlier case, we have to manually adjust the space between rollers after one passing. That means it will consume time. But in batteries, there are 3 to 4 pairs. So the distance between two rollers continually reduce, right? All rollers are provided with water spray, suitable for larger producers. After milling, sheets need to be washed thoroughly with pure water. You saw that when we are doing the rolling process, always we are adding water. Why you think so? What is the purpose of adding water? Always we are adding a water stream at the rolling process. Can anybody tell me? Any guesses? Yes? No. Because water spray will reduce the chance of getting sticky together, right? Roll එකත් එක්ක ඇලෙන්න තියෙන chance එක අඩු කරනවා. And on the other hand, it will wash away all the impurities available in the coagulum, right? In the left side, you can see what? Hand or power operated rollers, right? It's a hand operated roller. And right side, you can see 4 pair of rollers combined. It's a battery, right? Draining of sheets. Then what we need to do? We have to allow it to drain off all the existing water. Done by hanging on reapers or stacking on a slope platform in shade or a period of 3 hours. We are allowing 3 hours to drain off all the excess water. Dripping can be done on trolleys kept in the veranda of smokehouse. That means there's a separate trolley. We are putting all the sheets into that trolley and we are placing it inside the smokehouse when we are doing it small scale. So you can use the same equipment, same trolley to remove all the drain of all the excess water, right? Immediately after dripping, insert to a smokehouse and achieve a temperature of 48 degrees to 54 degrees. So that is the optimum temperature to allow it to dry. Either delay in transferring into smokehouse or obtaining 48 to 54 degree temperature will lead to rust formation. මොනවද rust කියන්නේ ළමයි? What do you mean by rust? What is rust? Yes? සිංහලෙන් අපි නිකාර මලකඩ කාලා වගේ rust එකක් දෙන්නේ නේ බෙන්දගේ. Okay. Then the fourth one is smoking, right? This is smoke sheet. Definitely we have to apply that practice, right? And sheets to absorb creosote and antiseptic substances to preserve rubber, right? Smoking should be done, right? To preserve the rubber, right? Creosote means carbonaceous chemicals formed by the distillation of various trans and pyrolysis of plant-derived materials such as wood or fossil fuel, right? Antioxidant effect of smoke dries the sheets without making them sticky. Normally, that is why we are having a water jet also to avoid stickiness, right? But when we are having applications of smoke, that means the antioxidant properties of that rubber will have the property of avoiding stickiness, right? Bright fire produces smoke deficient and antiseptic substances, and smoldering fire a heavy smoke, giving an unattractive appearance to sheets. So you know what the ways of denaturing the desired product, right? Then common faults of smoke houses are not sealing the space between roof and ceiling, right? So that means smoking not happens well. Not providing good drainage, right? If there is not good drainage, that means high moisture content available. Yes, high moisture content available, right? In the rubber sheet. Okay. This is a photograph from the smokehouse. So you can see the color changes, right? From white to brown color. So grading of rig smoke sheets. How you grade? Only well-prepared sheet rubber can be graded. Prior to grading, sheets are separated, inspected by any blemishes to remove by cutting. So what you are doing is you are taking one by one the prepared RSS and looking for any patches, any unwanted material in the sheet. So you can use a small sharp knife or something. You can remove the lumps, right? High quality rubber should be dry, clean, strong, sound, and evenly smoked. Right? By smoking unevenly, you can see some of the places are uh, you can see some dark patches, right? So it should avoid it. So you have to have the even structure, the even appearance, right? Accordingly, they are upgraded to number one RSS, number one X, right? That is the superior quality. Then RSS1, RSS2, likewise according to its quality. Normally in Sri Lanka, household level, they are producing RSS number 2 and 3, right? Latex production, right? The next one. Before that, I need 2 minutes to make a call. It's an important call. Just give me 2 minutes. I'll be back. Just give me.
Recording stopped.
Okay, now we are going to discuss about latex or the crepe rubber production. Latex crepe rubber or crepe rubber production. Mainly there are two types, RSS and crepe rubber. Types of latex crepe rubber are thin lace, blanket crepe, and sole crepe. So there are three different types of crepe rubber. Crepe is the purest form of natural rubber available in the market. So we have the highest demand in in the world market for Sri Lankan crepe rubber. It is the purest form of natural rubber. Sri Lanka is world's largest producer. Latex crepe is used for pharmaceutical and surgical rubber appliances, right? Like what operational items and baby items. So all those things we use. Then rubber components used in contact with food, right? Then infant item, toys, adhesive tape industry, winter shoe industry, right? So if you look at the shoe soles, some of the soles in this color, so that is from latex crepe. It is very durable. In the winter season, we can use it, right? Okay. What are the factory operations of latex crepe? What are the factory operations, right? First one is bulky, right? Like standardizing, before that process, we have to bulk. Field latex is collected to a rectangular bulking tanks of correct size. Depth and width should not be more than 1.2 to 1.10 meter respectively. So no need to buy out these dimensions. That's for your own understanding, right? Built out of brick or concrete with inside and bottom lined with glazed tiles. That means uh, glazed tile means the tile should be there to avoid other contaminations and reactions, because we have to take out the final product in the purest form in pure white color. So we have to avoid all the impurities, right? Outlet to be fixed 2.5 centimeter above the bottom. Then the standardization of latex. As in the RSS rubber, for uniformity of product through efficient mixing of chemicals. Level of dilution depends on the method of fractionation. There's a special process called fractionation. We will discuss that one. Manual, if it is manual fractionation, the required content, DRC content is 21.5. Then we have to reduce it to 15%. Aeration method, only 15%. If no fractionation, only 15%, right? Ultimately, we have to keep the DRC content as 15% after standardization, right? The third step is enzymatic discoloration. As I mentioned, there are some other particles in the rubber latex, right? That means we can see the dry rubber, we can see most of the water other than the protein, lipids, ions, likewise there are impurities. So we have to remove these things to avoid discoloration, right? Powder rapidly decomposes when exposed to air, right? Hence, use freshly prepared sodium bisulfate or metabolite. So the chemical that we are using is sodium bisulfate and metabisulfite, right? Added to grams for 100 kilo dry rubber discoloration. So these are the tanks. So and the fourth one by fractionation. Removal of yellow pigments after standardization. After standardization, adding all this one. So you can see some yellow pigments, right? Amount removed on the depend on many factors and generally between 12%, right? Method using for can be used. There are two different methods. Manually, we can use paddle method or there's a technique. What is that? Briskly stir, right? Briskly. We have to stir for 20-minute period with an interval of 10 to 15 minutes in between, right? What we are doing after adding to the coagulation tank or the tile glaze tank, we are using a paddle and gently stirring up to 20 minutes and allow it to keep another 10 to 15 minutes, right? Then again we are doing it, right? Occasionally dip hand to ascertain formation of yellow particles. Then we are dipping our hands and checking whether we can see any yellow color particles. If particles are forming, leave undisturbed for 10 minutes and then stir gently for form clots, right? Then what we are doing, again we are leaving it for 10 minutes, again we are stirring. Then all the yellow particles will stick together and produce clots, right? Yellow color clots. That is manual method. If we are doing it by mechanically, we can use the aeration technique using perforated pipes, right? Immense in latex pass compressed air for 10 minutes and 20 minutes interval. That means we are pushing, we are giving 10 minutes of air and we are leaving 20 minutes without air, right? Like in fish tanks used in the homes or that, I mean, when we are providing oxygen, the same thing happens. Aeration technique also same. Fraction will emerge to the surface with the froth form during agitation, right? Then it will collide. That means all the yellow particles will stick together. Aeration continued until no yellow particles are formed, right? So that is the aeration technique. Just know the basics, that's fine, right? Then the fifth process or the step is the coagulation tanks and coagulation. So you can see the coagulation tanks, right? Tanks should be situated at lower level than bulking tanks, right? So it's a different kind of a tank. It's very, it should be lower level. So you can convey or you can pass the fraction latex into the coagulation tanks. 2000 to 3000 liter capacity tanks lined with glazed porcelain, right? So you see the capacity. Normally in household level, farmers can't practice this because they have to have a good or high amount of latex, and it is not in their land, or they can't obtain that much of latex per day. And all the practices are very that means it is very labor intensive, and we have to do so many things. So it is very difficult to manage by a single person or a family, right? Size of tank should correspond to the mill size and coagulum divided to 7.5 centimeters slabs, right? Mill size means the size of the mill or the size of the roller will decide the width, right? අපිට roller pass කරන්න පුළුවන් width එක තමයි අපි coagulum එක හදන්න ඕනේ. Latex must send through a 60 mesh strainer. Why? Through this strainer, we are straining the latex to remove all the clots, that fraction, yellow particles, all those things will be strained, and we are getting the clean strained latex, right? Bleaching and coagulation carried out in these tanks. There's another process called bleaching. Bleaching with water-soluble rubber bleaching agent. Again, we are thinking about the possibility of getting discoloration. We need pure white product, right? So what we are doing, added to bleach carotenoid pigments in latex. That means there are some carotenoids in the latex, so we have to bleach it out, right? Sodium paratoluene thiophanate, right? No need to memorize, but 35% of that is used to as bleaching agent. Commercially available as Nexo bleach, Rupepa, RPA4 or polybleach. So remember the commercial names, right? Nexo bleach, Rupepa, RPA4, polybleach, right? 10 parts of chemical is mixed to 190 parts of water to prepare stock solution, right? So in factories, they have stock solutions prepared. So no need to prepare day by day. They are having the stock solution. So the required amount will be taken from the stock solution, right? 2 to 3 liters of solution required to bleach 100 kilogram of dye rubber. Two types of bleached rubber, UBR and FBR, right? So the seventh one is coagulation of latex, right? Coagulation of latex is the last process. So what we are doing, coagulation, always we have to provide an acidic environment, right? Formic acid is the best coagulant, right? Oxalic acid is recommended for salt cream when hardness of water is used high. You know the hardness, right? Hardness කියන්නේ මොකද්ද? ජලයේ කටිනත්වය කියන්නේ the hardness of water. කියුල ගතිය වැඩි ගතියක් දැනෙන්නේ. So if we observe that type of characteristics in water, we are adding oxalic acid, right? Latex need to be stirred during and after addition of coagulant and froth removed to prevent streakiness, right? If we found streaks for the final product again, it will be in low grade. So we have to avoid forming the streakiness, right? So the formic acid rate of application is there. Oxalic acid rate of application is there for your understanding and for your own knowledge. No need to discuss. Then the last one is milling. Now we coagulated the latex. Now we have coagulated slabs. The next process is milling of rubber. Coagulum can be processed into blanket cream, thin lace, or salt cream. 3 different processes. The milling rollers needed a macerator, diamond or spirally grooved and smooth depending on the type, right? Macerator is there, right? Then diamond and spirally grooved rollers are there. Okay. I will show you a factory process, then you can easily understand how this happens, right? Can you hear the sound? Just let me know quickly. Can you hear the sound?
Yes, sir.
Okay. This is the macerator, right? You can see the coagulator slabs first pass through the macerator, and you can see the water pass, right? there's always water to avoid into the macerator. And they are cutting down and passing through another water stream, right? Again, they are taking it. That's also the macerator. First, they are breaking down the coagulum. Now it's the macerator, right? This is the macerator. See the pure white color of the coagulated latex. Okay, I'm sorry. So you can see there are 3 or 4 passes through the macerator until the even structure is formed, right? See, they're folding the sheet and again passing through the macerator. See the water jet. See, there's always a water supply, right? These are the rollers. You can see how they produce. Then mill sheets from macerator is fed to the intermediate mills. Holes and thickness of sheets will be reduced. You saw that there are some holes in the sheet. Now there is no holes, right? See, they are passing 2 to 3 times, and finally it will be a thin and even sheet. Okay. So this is another pass. You can see after that they are cutting into different lengths in stacking, right? These are the crepe. See? Okay. So this is how you can they produce crepe rubber. And the last process is drying of crepe latex. Okay. though natural air drying could be done, warm air drying is essential for the quality, right? Because we can't expect sunny days in each day of the month, right? There are some days with high humid and what do you call the high humid and rainy days. So it will not. Initial moisture levels lies between 10 to 20, 12 to 20%, right? Drying takes place in two stages. Constant rate period, that means up to 3% of moisture, it is constantly reducing. Then falling rate, that is less than 0.5, right? This last or the second step is very difficult to achieve. So the falling rate period is the 85% of the total drying period, because we have to ensure that the final product is well dried. Otherwise, the keeping quality will be low, right? Drying system for crepe rubber. Loft, warm air, forced air, and vacuum. There are four types, right? Loft means natural air drying. I will show you. Natural air drying could be done in loft if good weather prevails, right? Average thickness of lasers is this. Takes 4 to 6 days, right? To dry, it takes only 4 to 6 days. Warm air drying, multi-story drying tower, right? Warmed by boiler radiator system in ground floor. So ground floor is used to have the installment of the boiler. So by that, it will generate heat, the warm air, and it will dry the latex. Source of heat is a slow combustion of fuel stove. Ventilation is by natural upward draft, right? That means the upward air is supplied from the bottom and it will go to the upper stories, right? Temperature of the building is kept at 34 degrees. Drying completed in 3 days, irrespective to the weather conditions. So, in natural air drying, we have to or the drying process is affected by the rain or the moisture conditions in the surround. But in warm air drying, it is happen irrespectively in 3 days. That is less than the natural air drying. The forced air drying is developed by modifying boiler radiator system. Hot water circulated among small radiators using a pump, right? Hot air is blown into the drying tower through a duct system, right? Radiators and air blowers are positioned outside drying tower and air ducts inside, right? Ground floor can be used for drying, increasing the capacity of drying tower by 33%. That means in warm air drying, we can't use the bottom or the ground floor because we have to install the boiler. In force feed, there's a duct system, so we can install the boiler outside and you can use the ground floor also, right? Then vacuum air drying. What happens? We are creating a vacuumed environment inside the chamber. Drying is fully sealed. Drying in a fully sealed chamber. A partial vacuum created by suction of air. Air enters from the bottom through a series of tubes. Size of drying chamber depends on daily crop. Drying time is 12 to 16 hours, right? So you can see the efficiency of that drying process, right? You can see different types of drying chambers. And these are the grades of crepe rubber, right? First one is latex crepe, food and pharmaceutical grade. That is the highest grade without natural proteins and adding bleaching agents, right? Catheter tubes, blood tubing, surgical rubber appliances, baby toys, infant teething rings. The teething rings means that allow the babies to chew, right? So it helps the grow their teeth, right? In food industry. So that is the highest grade. Then adhesive grade, right? Pure white, no gel formation, right? Adhesive tapes, gums, glues, sticky pads, rubber derivatives, all those things happen from this grade. Then general pervasive grade, that is pure white shoe soles, colored products. Then low nitrogen grade, low nitrogen ash levels. That means low water absorption. Water seals, aircraft tires, bridge bearings. So you can see the vast spectrum of uses of natural rubber, right? Then yellow fraction grade, rice huller roller surfaces and earthquake protectors. Then premium quality product. That's Lankapreen. Lankapreen is very famous in the other countries, right? Okay. So what are the advantages and okay, then there's another product called centrifuge latex, right? I'm not going to discuss about centrifuge latex. Centrifuge latex means we are keeping the latex in concentrated form, so we can use it to produce different deep products like gloves, rubber threads, right? Adhesive. So it is another industry. So advantages and uses. Lower cost of transportation and shipping. Sometimes we are producing centrifuge latex and we are transporting or we are exporting it as it is, right? Raw material for latex based industry like dipped goods, rubber thread, latex foam, cast products, carpet backings. The carpet that we are using in household, if we are using in a tile floor, if it is not carpet back, definitely it will slip, right? But if the carpet is formed with rubber or the centrifuge latex, it will stick to the ground, right? Rubberized coir, there are coir mattresses now also available, and it will mix. Otherwise, coir will go here and there, right? So we have to keep it intact. So we use it as a adhesive, right? Okay, now your homework is refer and learn from online sources for centrifuge latex production, right? So you have to learn these things. I will give you one or two questions from centrifuge latex production. So familiarize with the main steps of centrifuge latex production, right? Okay, that's all about processing of rubber. Any questions? Now you can ask. Do you have any questions? Okay. Okay, then if you don't have any questions, just wait for a minute. I will ask Sagara sir at what time he will be taking the lectures. Then you can have the break. Please don't go anywhere. Just give me a minute. I will give a call and let you know.
Excuse me, sir. Homework
Yes.
එක අපේ පොඩ්ඩක් පෙන්නන්නකෝ.
Pull up. Oh, yes, can. Read and learn from online sources for centrifuge latex production. So you can take your break. Sharp 12:45. Sagar sir will take the session about coconut processing, right? So you can take the break now. Be online sharp around 12:45.
Sir, excuse me.
Yes.
Can I have? Will you give the slides?
I'm sorry, I can't hear you clearly.
The slides. Will you upload?
Yes, I will share this. Yes, I will share these slides. I will try to upload it today itself, or otherwise tomorrow. Definitely, I will upload it. Tomorrow there's another group, no? Definitely, I will upload to the LMS. All the previous lectures are there, so I will upload these slides also. Right?
Thank you.
Okay, then. Thank you very much for listening me, and have a nice day. Yeah, that's all. Thank you.
Yes, sir.
Okay, then you have another session. So that session we will discuss about the coconut processing, harvesting and processing. So now it's your lunch time. Shall we start at 1 o'clock? Is it okay? Or 12:45? What is the better?
1 o'clock is better, sir.
1 o'clock. Okay. Then take your lunch and we will meet again at 1 o'clock. We will talk about the coconut processing technologies. Okay.
Recording in progress.
Okay, so I think this is your last lecture on this course module, commercial plantation crops. So under this subject, last day we discussed about mostly the agronomic part of these major 3 plantation crops. They are tea, rubber, and coconut. And I guess in the morning sessions, you had a knowledge about the harvesting and processing technologies of tea as well as the rubber. So now I am going to discuss with you about the harvesting and processing technologies of coconut. So within these 2 hours, I would like to discuss with you these things basically, as well as at the end of this lecture, you will be able to categorize different coconut-based products. Later we will discuss them. What are the different products we can produce using coconut? Some are edible products, some are non-edible products. We will discuss them and describe processing method of different coconut-based products. Describe different methods of value addition, as well as we will discuss what are the value addition products available and what are the potential we can produce value added product using coconut, and apply the knowledge to develop various coconut based products. So those are the intended learning outcomes, and at the end of this lecture you will be able to discuss those things. Okay, then last week we discussed about up to the field planting and aftercare operations. So we will discuss from that point. So 12 months old nuts are harvested at the interval of 30 to 45 days for seed as well as copra making and also the cooking purposes. Now you know. Okay, then quickly we will just refresh your memory, and can anyone tell me what is the nursery period of the coconut plant? How many months it will take? Anyone? Nursery period?
9 to 12.
9 to 12, very good. So 9 to 12. And then you know there are several coconut varieties or forms are available. We discussed those things last day. So according to the variety as well as according to the soil and the climate conditions, so normally it will take around 5 to 6 years to start in bearing period, 4.5, 5, 6 likewise. So after that, in during the morphological part also I discussed, normally coconut plant produce 1 inflorescence per month. So then we can harvest a bunch of coconut nut or fruit normally within 30 to 45 days interval. මාසයකට සැරයක් අලුතෙන් ඉන්ෆ්ලුවන්සස් එකක් හැදුනට අපිට harvest කරන්න සාමාන්‍යයෙන් mature වෙන්න ගත වෙනවා කාලයත් එක්කලා අපිට harvest එකක් ගන්න පුළුවන් interval එක harvesting interval එක වෙන්නේ දවස් 30ත් 47ක් අතර කාලේ. So 7 to 8 there's a printing mistake. 7 to 8 months all nuts are harvested for tender nut purpose. Then you can differentiate the difference between these 2 sentences. Normally for the copra production or cooking purposes or as well as the seedling purpose, we harvest coconut older than 11 or 12 months. As well as for tender nut purpose, it means for the coconut water, like coconut water based products. So we normally harvest coconut at 8 or 7 months age level. So nuts which are 11 months old give fiber of good quality. So as well as if our requirement or the final product is the fiber, so we can harvest our nut around 11 months age. So likewise, according to our purpose, according to the end product, we can determine the harvesting time. So normally for the oil production or the cooking purpose, we should harvest 12 months or 1 year old nuts. So on an average, 8 harvests can be obtained through the coconut palm produce inflorescence every month. As I discussed earlier, normally a coconut palm, coconut tree produce inflorescence in every month. It means per year 12 inflorescence. But we can obtain harvest per year around 8 harvests. අපිට මාසයකට සැරයක් හම්බුනාට අපිට සාමාන්‍යයෙන් harvest කරන්න පුළුවන් තත්ත්වයට mature එකටපත් වෙන්නේ ඒකෙන් bunches 8ක් වගේ තමයි per year. Okay, then we will discuss about what are the harvesting method we can use. So normally there are 3 harvesting methods are available. Climbing method. So normally it is the common method as well as labor intensive method. So coconut climber, they are trained people. So they climb to the coconut plant and using knife or hand, they take those coconut bunches out of the tree. So as well as a power tiller operated ladder also available. I will show some of photographs, then you can get a better idea. And tree climber or the climbing cycle like equipment also developed. So using those technologies, research and the development, now we have developed most easy methods or technologies to harvest coconut. Okay, so these are the methods, climbing methods. So this is a normal things. Sometimes we use ring. People so use a ring, making using the cloth or any other material to climb this plant. And also we can use the harvesting pole. This is also a very easy method. So we can use a pole, connect with this kind of knife, and we can easily harvest using a harvesting pole. So as well as a tractor mounted coconut climber also available. So here we can adjust this unit, the height of this unit according to the plant height. And there's a person, so he can easily reach to the coconut bunch and harvest easily. Unit එක හරහා පුළුවන් ගහට reach වෙන්න. As well as the tree climbers, there are several tree climbers. Here you can see this equipment, and also using this tree climber. Here in the last picture you can see a woman, so they also can easily reach to the coconut bunch. So then බලනකොට ගැහණුව පිරිමි විතරයි නෙමෙයි දැන් ගැහණුවයිට පොල් කස් නගන්න පුළුවන් because there are these improved technologies are there, then everyone can use them. Okay, then let's discuss about the coconut production in Sri Lanka. So the annual coconut production in the country today range between 2,800 to 3,000 million nuts per year. So this is the nut production, coconut nut production per year in Sri Lanka. So what do you think? Is this amount is sufficient, or are we self-sufficient from the coconut nut? Actually, no. Not only the coconut, we are not self-sufficient with the vegetable oil. Coconut also a kind of vegetable oil. We are not self-sufficient. Api සම්පූර්ණයෙන්ම මේ edible oil වලින් self-sufficient වෙලා නැහැ, because we have to pay a lot of foreign money or lot of money to import these edible oil or the vegetable oil as well as coconut oil also we import from other countries like Malaysia. We import the oil palm also. So likewise, we import a lot of oil because our production is not sufficient to match with our demand. So to satisfy the demand for the both domestic consumption and also the processing industries, we use coconut oil for the bakery industries, cooking industries, biscuit industry. Likewise, there are various industries consume coconut and coconut oil, desiccated coconut for various purposes. So those processing industries also we need coconut. So Sri Lanka must achieve the annual production target 4,000 million nuts. It means to self-sufficient with the coconut. So at least we should produce 4,000 nuts per year. But currently we only produce 3,000 nuts per year. So you can see there is a huge gap between the production as well as the demand. There's a huge gap between these two. That's why we have to spend a lot of money to import coconut and also other vegetable oil from other oil producing countries to match our demand. ගොඩක් අපි vegetable oils import කරන්න හේතුව අපේ නිපදවන oil ප්‍රමාණය නැත්නම් coconut nuts ප්‍රමාණය අපිට ගොඩක් මදි වලින් තමයි තියෙන්නේ. Okay, I think now we have a clear idea about the basic things, our production and also those things. So what are the things we can do, or what are the your suggestions to improve this our coconut production? What do you think? Any suggestions? Now our production is not sufficient to complete with our demand. So what we can do? Any idea? Please talk. I think last day, Shehani, are you there? Shehani, can you hear me?
Yes. Yes, sir.
Yes. Okay. I think last day you gave answers. So do you have any suggestions to improve our production, the coconut production? What do you think? To enhance the nut production, what we can do? Now, you know, normally the coconut lands, most of the coconut lands are we use for our construction purposes, development purposes, no? So our land area is very limited. So what we can do? Shahani, do you have any idea? Okay, then there are a lot of things we can do. Here I have mentioned few of them. So genetic improvement of coconut. So we can't extend the land area. අපිට තියෙන land area එක වැඩි කරන්න බෑ. Therefore, we can improve, we can enhance the land productivity. To increase the land productivity, these things we can do. Genetic improvement of coconut, as I mentioned earlier, nowadays using Coconut Research Institute, they have developed several hybrid varieties. By crossing the dwarf varieties and tall varieties, they produce kapru and kapseta like hybrid varieties to enhance the productivity. So we can do them, as well as development of in vitro propagation protocols also we can practice to enhance the productivity and enhance soil quality, rehabilitate the coconut soil. So by improving the soil fertility, soil condition, we can get a higher yield. So those things also we can use, because most of this coconut cultivating lands are not very good soil conditions we can identify. Those are sometimes the arable soil. So we can enhance the soil quality. So those things also we can use. And manage soil water. So we can use the irrigation system. There are low-cost irrigation technologies are available. Drip irrigation system, especially the drip irrigation system used for coconut cultivation. We can use them and develop improved farming systems. So as I mentioned last day, we can integrate coconut and other crops together, intercropping, as well as animal husbandry. Also, we can use animals, cattle or the sheep, like animals integrated with the coconut to enhance the productivity and develop appropriate cultivation practices in non-traditional areas. So as well as the cultivation practices means the economic practices, weeding, fertilizer application, soil management practices. So those things sometime still we are using non-appropriate methods sometimes. So we can use the proper method to enhance the productivity and mitigate and adapt to climate change effects. So I think I didn't discuss about the temperature behavior that affect to the flower inflorescence or the proper plants flower reproductive stage. But there are the temperature is the critical factor for coconut nut production. So nowadays, the climate change is the global effect, the climate change. So according to the climate change, the temperature is increasing day by day. So that temperature mainly affect to the production of the crop, not only the coconut, all the crops. So we can do the mitigation or the adaptation method to minimize the impact of the climate change. So in the one hand, we are trying to reduce the impact of the climate change, as well as in the other hand, we should get the mitigation option, so the adaptation option to combat with the climate change, and developed sustainable pest and diseases management system. So the last week we will discuss what are the pest and what are the severe diseases affect to the coconut plantations. So some pests, they are heavily damaged to the plant, and we can't recover the plant after affecting those kind of diseases of the pest. Therefore, we can use a sustainable pest and disease management system. I think you may heard that the integrated pest and disease management system. So those kind of sustainable methods we can use to control the pest and diseases, because pest and diseases affect to reduce our production in a higher amount, and developed the technologies for value addition and the process improvements. So not only the field, as well as during our factory or during the production process, also we can improve the technology to get the higher production and mechanize farm and industrialized operations. So as I mentioned in the previous slide, currently there are some development methods are available for harvesting, climbing to the plant. So the earlier it is done by a man or using a labor force, but nowadays that also mechanized. So those technologies we can improve. So manage uncertainty of the yield and market. So we can control the market. So we can predict the future trends of the production and the market. So those things also we can do, and develop technologies to reduce the cost of production by using the sustainable pest and disease management method, fertilizer management systems. We can reduce the cost of production and transfer technologies to stakeholders. So most of the time, you also now you will get some kind of knowledge about the coconut farming and the processing. So you can you can distribute your gain knowledge to coconut farmers in your area. So likewise, we can transfer our knowledge to the coconut planters or growers. Then we can improve their knowledge also. So likewise, these are some strategies or things we can practice to get a proper yield. So these things we can do. Okay, so I got a message also. How many cultivation or the nuts can we take from one coconut tree? This is the answer. So this is the yield potential. So normally the coconut palm can we can obtain around 80 to 100 nuts per year per palm. So this is the average value. So සාමාන්‍යයෙන් පොල් ගහකින් අවුරුද්දකට අපිට ගෙඩි 80 100ක් අතර ප්‍රමාණයක් ගන්න පුළුවන්. So this is the average value. This value or this amount, the nut amount, depend on the variety as well as the fertilizer requirement and the age of the plant. So likewise the climate conditions. වලදන සමහර කාලවල ගොඩක් අහලා ඇති සමහරට මේ පාර මුරේ පොල් ගොඩක් වැඩි කියලානේ. කොකොනට් කල්ටිවේට් කරන අය ෆාම් තියෙන අය මේ පාර පොල් මුරේ පොල් අඩුයි කියනවා. So සමහරට වැස්ස නිසා සමහරට තද පැවිල්ලක් ඇවිල්ලා. So likewise due to the drought condition, the weather conditions also affect to the yield. So normally the dwarf varieties, this is the average yield, 70 to 80 nuts per year. The tall varieties is a little bit higher than the dwarf variety, 80 to 100 nuts per year. And also the hybrid variety. Here you can see now most of the time we use hybrid varieties because they produce higher amount of nuts per year. So with compared the tall and the dwarf varieties, hybrid varieties are producing higher number of nuts. So normally the 100 to 130 nuts per palm per year. So this is the average yield potential for each major coconut farm. Okay, then let's discuss about what are the coconut-based products. So what are the products we can produce using coconut? So normally, mainly we can divide all those coconut-based products into 3 groups. So can anyone guess what are those 2 groups? Any guesses, please?
Coconut oil.
Yeah, coconut oil. Yes, coconut oil. I'm asking what are the 2 major groups? So coconut oil is a kind of product. So what is its group? There are several products, no? Coconut oil, coconut milk, coconut water, and also the coconut fiber, coconut mattress also we can produce using coconut robes. So what are the 2 major groups?
Kernel products and husk products.
Kernel products and husk products, yes, but it not cover all those products. Okay, then I will show you. Mainly we can divide those products into edible products and non-edible products. Okay, these are the 2 groups. I think you know edible products. Edible mean we can consume or we can eat. කෑමට ගන්න දේවල්, no? So the non-edible mean we can't consume. Consume mean we can't eat them. So mainly we can divide those products into edible products and the non-edible products. Okay, now I think you can tell me the list of the edible products as well as the non-edible products. So these are the products. So mainly, as you said, the kernel products as well as water and sap-based products are coming under edible coconut products. So what are the kernel products? Kernel, I think now you know what is the kernel. මම දැන් හිතනවා ඔයාලට පුළුවන් කියලා. මොකද last week we will discuss the component or the part of the coconut fruit. අපි fruit එකක අපි components කතා කරානේ. මම හිතනවා ඔයාලට දැන් මතක ඇති කියලා. So the outer layer we can identify the exocarp. So after that we can identify the mesocarp. Mesocarp is the fibrous region. So after that we can identify the endocarp. So endocarp කියලා කියන්නේ පොල් කාට්ට shell. So after that we can identify the endosperm. So endosperm එක තමයි අපි coconut kernel එක කියන්නේ. අපි අරගන්න coconut මදි. සිංහලෙන් කිව්වොත් coconut madi. So the kernel we can use to produce desiccated coconut. Here DC means desiccated coconut, and the copra and the oil. So oil mean virgin oil, coconut extra virgin oil, like there are several types of oil. So mainly these are the three products we can produce using coconut kernel. And then the coconut water and the sap based products. So coconut water mean අපි දන්නවා පොල් ගෙඩියක් පැලුවාම ඇතුළේ තියෙන වතුර තමයි අපි coconut water පොල් වතුර කියන්නේ. What is the sap? Do you know the sap?
Fuchsia.
Fuchsia නේ? ඔව් fuchsia. අපි සාමාන්‍යයෙන් we use sap coconut, not only the coconut, in the other palm trees like the kitul and the palmyra or tal. So those plants.
මීරා කියනවාද?
අපි රා පෙර විශේෂයෙන්ම රා සහ පැණි ඒ වගේම හකුරු හදන්න අපි පාවිච්චි කරන්නේ මෙන්න මේ සැප් එක ටෙලිචර්. මේ හැම දෙයක්ම අපි සැප් එකෙන් තමයි හදන්නේ because coconut as well as the palmyra and the kitul. Palmyra can තල් වලට and the kitul, those three plants we use to produce obtain the sap. So coconut sap we use to produce vinegar, toddy, wine, as well as natadi toko. So mainly those sap also we can divide into two groups. They are the fermented product as well as the non-fermented products. So the toddy, wine, vinegar or arak. පොල් අරක්කු කියලා කියන්නේ පොල් අරක්කු. Toddy means the raw wine. And also the vinegar. So these are the products we can produce using coconut sap, as well as during the production we put the sap to the fermentation process. මේක අපි පැසීමකට ලක් කරනවා. fermentation කියන්නේ පැස වෙනවා. පැසීමකට ලක් කරනවා using the microbes. Yes, using the microbes. Microbes like and අපි සුදුජීවීන් භාවිතා කරලා Saccharomyces, it's like the yeast. Saccharomyces is නැත්නම් අපි yeast කියලා අපි සාමාන්‍යයෙන් හඳුන්වන්නේ. Using those microbes we ferment these sap to produce vinegar, toddy, wine and arak like fermented products. So as well as the sap we use to produce non-fermented products. Non-fermented products means we do not use the microbes. Normally using the heat අපි රත් කරලා මෙන්න මේකේ තියෙන ජල වාෂ්පමානය we remove the we allow to evaporate the extra water and because the coconut sap is coconut sap rich in the sucrose like the sugar, therefore we use that sap to produce the coconut crackle or the අපි පැණි කියලා හඳුන්වන crackles as well as the hakuru. So those are the products we can using the coconut sap. Okay, then the non-edible products. So non-edible products, most of the time for the industrial purposes, we use the coconut shell and husks to produce various kind of non-edible products. So the shell or the ඇතුළෙම තියෙන coconut පොල් කට්ට කියන්නේ. So the shell we use to produce the charcoal, activated carbon, or as well as for producing the ornamental products. So different ornamental products are available sometime in the supermarket also. You may have seen those kind of products. Some the products, ornamental products, we can put in our table. So likewise there are several ornamental products.
පොල්කටු බොත්තම් තියෙනවා.
බොත්තම් සහ විවිධාකාරයේ පොල්කටු හැදි spoon also as well as අපිට ඔයාලා දැකලා ඇති මේ මග් වගේ දේවලුත් නේ පොල් කටු වලින් හදලා තියෙන. So they use coconut shell and they polish and they colored ලස්සන පාට කරලා ornamental products හදලා තියෙනවා. I will show you later. I will show you some photographs. Then the coconut husk. So coconut husks also we can identify several products producing coconut husks. Mainly the coconut husks contain the fiber as well as coir pith. So fiber, I think you know fiber. So what is mean by the coir pith? Any idea? Coir pith?
කොහොබත්
Kohubat, yeah. Coir pith mean in between the coconut fiber we can identify coir pith, kohubat. Kohu fiber can කෙදි අතර තියෙන කොටස තමයි අපි coir pith කියන්නේ. So normally the coconut husk contain both fiber and pith. So fiber we used to produce the mattress as well as the brooms and also the geotextiles also. We use fiber to produce geotextile. Geotextile can අපි පොළොවට අපි පාවිච්චි කරනවා especially to avoid the soil erosion. We cover the soil surface using the mattress like structure. So that's we call as
හලන්ද
geotextile. අපි ගොඩක් එක පාවිච්චි කරන්නේ පොළොවට කාදිනේක වලක් වන්න පොළොවට කව එකක් විදියට geotextile as well as the coir robes ලනු කඹ, so those items. And the coir pith we use to produce the coir pellets, coir bricks or the coir pots. So there are several especially the value added products are available. So coir pith is a very good source for producing the planting medium, especially to the greenhouse plant production. We use the coir pith based structures. We call them as a substrate without any sand or without any soil. We use coir pith substrate to grow our plants, especially in the polyhouse conditions, because the coir pith contain the higher amount of or the higher ability of absorb water. That's why we use coir pith as a mulching material also. So coir pellets, bricks and the coir pots we can produce using coir pith. Okay, I think now you have a clear idea about what are the products we can produce using coconut. What are the edible products and what are the non-edible products? Okay, then I will mainly focus some of those important products, not all those products. I am not going to discuss all them. Some of products I will discuss it to you now. Okay, so as I mentioned earlier, these are the products. By looking at those pictures, you can identify is this edible or the non-edible, as well as I guess you can identify so what is the plant material. So what is the plant component we use to produce them. So the desiccated coconut, we use the kernel to produce desiccated coconut. Then the copra and also the kernel we use to produce copra. So copra, the final product is the oil. අපි copra වලින් අවසාන product එක වෙන්නේ coconut oil. Then the punak, animal feed, punnakku, as well as a jam also we can produce, and the coconut toffee like the sweet items also we can produce using coconut. Then the vinegar, it is a sap-based product, and the coconut wine, it also the sap-based product. Then natadi cocoa, අපි මේකෙත් අර coconut pol made tender, the immature coconut tender sperm we use to produce the natadi cocoa like sweet item, and also the crispy product from the embryo. So the developing embryo also we can consume. We make a single කියනවා pol palpi කියලා. Yes, palpi. So then the sperm we can in the seedling stage we can use the embryo as a crispy, producing the several crispy products, and also the coir robes, brooms, and the coir mats. So those are the things we can produce using coconut fiber. Then the charcoal, shell-based product, and the activate carbon also we can produce using shell. As I mentioned earlier, these are the ornamental products we can produce using coconut shell, and also coconut ice cream. I think some of you have the experience of this taste. It is a very good taste coconut ice cream. අපි සාමාන්‍යයෙන් milk ice cream වගේම හොඳ flavour එකක් තියෙනවා coconut ice cream වල. කාල නැත්තම් කාලා බලන්න හරි රසයි. And the coconut curry paste also we can produce. These are some value added products. Coconut curry paste, coconut jam, coconut ice cream. These are value added products. And the bottled coconut water also nowadays, those coconut water also available in a bottle form. And also the coir based proofing sheets also now available, coconut proofing sheets. And also this is the geotextile. So geotextile normally we used to protect the surface of the ground. දැන් මේ වගේ එකක් අපි ඉරෝෂන් එකක් වෙන තැනක තියලා මේකෙන් අපි කවර් කරොත් මොකද වෙන්නේ? ටික කාලෙකින් මේ ටෙක්ස්ටයිල් ජියෝ ටෙක්ස්ටයිල් එකේ පැල හැදිලා එතකොට soil surface එක cover කරනවා. So likewise we can reduce the soil erosion. Okay, then the coconut and the coconut based products could be categorized into kernel based products, shell based products, husk based products, and fiber based products. So those are the major products. Earlier I categorized them as edible and non-edible. Here I am again categorized according to the plant or the coconut part of the plant. So if you produce the products or the desiccated coconut or the oil or the copra, so we use the kernel, we use cell to produce the activated carbon and also the charcoal, and the cocoa peat we used to husk we used to produce cocoa peat, and also the fiber we used to produce brown fiber, white fiber. There are several kind of fiber also there. We will discuss them. Okay, first we will discuss about the manufacturing of desiccated coconut. Okay, so before going to this part, I will share with you a small video clip. So in that video clip, you can get a broad idea about the products we can produce using coconut. Then I will share a small video clip with you. Then you can watch it and you can get more idea. Okay, then can anyone tell me whether you can see my shared video? Can you see the screen? I have shared a video.
Yes, sir.
Okay, then I will play it. Watch this video and you can get a broad idea about the things I have discussed with you a few minutes later.
Coconut harvest and shell removal. Coconuts are grown in hot and humid tropical climates. The two most common harvesting methods are the climbing method and the pole method. This pole method is safer and faster than the climbing method. This is how the coconut shell is peeled to be used for commercial production. Cocoa peat production. Cocoa peat is produced from cocoa ore, which is simply the pith layer surrounding the shell of a coconut. In recent years, it has been used as an excellent plant growing medium. Coconut shells that come to the factory are processed in this way and become ready to be cocoa peat. Cocoa peat can be used in many areas such as greenhouses, nurseries, hydroponics, and floriculture applications. Cocoa peat is extremely absorbent. It is also excellent at retaining water and can also release it slowly so your plant can absorb it better. Cocoa peat provides the perfect environment to keep your plants healthy due to its antifungal properties. It's also mold resistant, which helps protect your plants from disease and prevent root rot as they grow. Milk, oil, flour, water, and other products. A wide variety of products can be obtained from coconut. These include milk, cream, oil, powder, water, copra, dried flakes, and more. The coconut shell is relatively hard, but can be broken. Because its shell is hard, it can be used as an ingredient to make craftworks. There are many coconut palms on the coasts of Indonesia, India, America, South Sudan, Bangladesh, and Tanzania. People of this area use coconut milk in cooking. Women use coconut oil as oil for their hair. Coconuts arriving at the factory are first processed and their interior is reached. Then they are thrown into the machines according to the product to be produced. The flesh of a coconut is white and can be eaten raw or used in cooking. It is used in many of the foods we eat for flavor. The concept of coconut water and coconut milk is confused by many. Coconut milk is obtained by pressing grated coconut meat. It is used for cooking various dishes. The fat found in coconut milk is less than in coconut cream. Coconut milk can be diluted to create coconut milk beverages. These have much lower fat content and are suitable as milk substitutes. If there are any of you who love coconut milk, write them in the comments. As you can see, even ice cream is produced from coconut. Coconut is a very nutritious, fortifying, and fattening food. Coconut has high-quality protein content containing all amino acids. It is also rich in potassium, sodium, magnesium, and sulfur. The energy values of dried coconut are quite high. A ripe dried coconut is also effective in the treatment of excess acid problems in the stomach and provides relief to the patient. Coconut flour has also been developed for use in baking to combat malnutrition. Coconut oil is commonly used in cooking, especially for frying. It can be used in liquid form like other vegetable oils or in solid form like butter. Coconut fiber mat and coconut rope. Coconut fiber offers an environmentally friendly alternative to produce many product types. Wonderful products such as wicker rugs and rope are produced from coconut fiber. Humanity has made the most of the coconut resource until now. They have consistently come up with a variety of coconut-related products. In 2020, world production of coconuts was 62 million tons, led by Indonesia, India, and the Philippines, with 75% combined of the total.
Okay, I think you got a kind of idea about what are the products we can produce using coconut. And I downloaded that video clip from YouTube. There are so many videos, so you can, after this lecture, you can find some of relevant video clips. Okay, then we will start to discuss about manufacturing of desiccated coconut. So I think now you know desiccated coconut is a product we can produce using coconut kernel. So Sri Lankan desiccated coconut has a high demand all over the world. So in the last day we discussed Sri Lanka is the fourth largest coconut producer in the country. So it has unique characterized pure whiteness in color, taste, and also the aroma. So frequently used in the food processing and also the confectionery industries such as biscuit industries and also decorating or as a topping, we use desiccated coconut. So what is desiccated coconut? Do you know about desiccated coconut? Desiccated coconut කාලා තියෙනවා කවුද?
Really, Paul?
Oh, really Paul. මාදේ තමයි අපි desiccated coconut කියන්නේ. So actually this is a dried form, yes, very good, as well as the disintegrated white kernel. Disintegrated means we do this process in a very strictly hygienic conditions. If not, this product may be damaged with the microbes as well as the other conditions like the extra moisture conditions. So those are the things maybe have happened to the product, and also the deformation of the color, taste, those things. Okay, so we can define the desiccated coconut like this. This is a dried, disintegrated white kernel of the coconut processed under strict hygienic conditions. So the video clip also, you may notice that the workers inside the factory, they wear masks, gloves, and also the boots, because inside the factory, strictly these hygienic conditions or hygienic practices are practiced. Therefore, they follow them. Okay, then the first step is the seasoning. So before that, we should harvest. So after that, the seasoning. So seasoning means we have to keep the harvested coconut nuts around 3 to 6 weeks after the harvesting. So during that period, so facilitate the shell removal. So during that the seasoning period, it will enhance or it will facilitate the shell removal during the process. So we have to remove the kernel from the shell. So this seasoning period help to easily remove the kernel from the shell, as well as improve the quality of desiccated by reducing the water. We can get a quality desiccated coconut by keeping our harvested coconut nuts for 3 to 6 weeks for seasoning, and also allow green husks to burn. And also during this time period, the color of the outer layer of the nuts turn into brown color from green color. Okay, so then next step is dehusking. So as you can see in these two pictures, there are manual method also. Now there are some improved mechanical method also there. So dehusking mean removal of the coconut husk from the shell. So first, after seasoning, we should remove the shell and we should separate the nut. So therefore, manual method using the lever and also the spike, we can remove the shell and the husk and shell, or we can use the mechanical methods. So these are the equipment developed for dehusking purposes. Then the hatching. So hatching means now we have to transport the nuts to the hatching area immediately after the dehusking. So hatching means store on the ground under cover of the palm leaves for use of later day. The next day we use them. So during that time period, we have to inspect the nuts. We have to remove any damaged nuts or spoiled or damaged nut, because if we use the spoiled or damaged nut for the production, it will affect to the whole process. අපි කුණු වෙලා තියෙන පොල් ගෙඩියක්, damage වෙලා තියෙන පොල් ගෙඩියක් ගත්තොත් ඒතර ඒක නිසා අනිත් සම්පූර්ණ product එකම නැති වෙන්න පුළුවන්. Therefore, we should inspect them. We should carefully observe the damaged or spoiled nuts, and we have to reject them. Then next step is removal of the shell. So the labor also we use for the manually removing of the shell from the kernel, as well as there are some mechanical method also available. So the person involved with this process we call as hatchers or hatcher. අපි hatcher කෙනෙක් කියලා තමයි කියන්නේ මේ shell එක ඉවත් කරන පුද්ගලයාට. So an experienced hatcher may de-shell between 150 to 300 coconut per hour. So this is her or his productivity. Normally per hour they can remove the shell around 150 to 300 nuts. So removed shell are used to produce charcoal. Now earlier also during the dehusking, that stage we separate the husks from nut. So this husk normally we can use for producing husk-based product. It means fiber or coir media. Likewise, we can pass to the next step. Then here, during the hatching, we remove the shell. Then this shell also we can use to produce shell-based products. Now you know what are the products: charcoal, activated charcoal, like things we can use. You can use to produce using shell. Therefore, these things are byproducts now. Then the de-shelled nuts. Now we have only the kernel. So this kernel now put into the wire basket for then the pairing. So the next step is pairing. Let's see what is the pairing. So here in this picture also you can see the hatching or removal of the shell using the manual methods. This is a hatchet. අපි අර පොඩි පිහියක් වගේ ගන්න තියෙනවා. මේකෙන් තමයි කෝල් ගෙඩියට තට්ටු කරලා cut අයින් කරන්නේ. This is the manual method, as well as this is the machine. There's hatching machines available. අපිට මේ විදිහට පොල් ගෙඩිය අල්ලුවාම මේකේ තියෙන මේ දැති වලින් මේ පොල් කට easily remove. Then the next step is pairing. So the pairing means removal of the tester. I guess in that video also you notice that this process is normally done by women because this is a kind of easy task, as well as they use special paring knife for this purpose. So pairers and also the hatchers are work as a team. Now hatchers means the people who remove the shell. Pairers means the people who remove the testa. Testa means අර outer layer එක. මතක නම් අපි foot එක කතා කරලා ඉස්සෙල්ලා කතා කරා. shell එකයි kernel එකයි අතර තියෙනවා testa එකක්. brown color testa එකක්. අපි කුරුට්ට කියලා කියන්නේ. මෙන්න මේ කුරුට්ට ඉවත් කරන තමයි pairing සිද්ධ වෙන්නේ. so the කුරුට්ට ඉවත් කරන පුද්ගලයන්ට අපි කියන්නේ pairers කියලා. එයා තමයි කුරුට්ට ඉවත් කරන්නේ. So normally the pairers and hatchers are work as a team. Hatchers remove the shell, then the pairers remove the testa. So they are work together as a team. Then paired nut. Now we have removed all the brown color testa. Then we have white color kernel. So then we have to split the kernel because inside the kernel there's a coconut water. No. Then we have to split and open the coconut nut, and also we have to remove the coconut water. Then the washing. So during this stage also you can see there are several byproducts. So the testa, නැත්නම් කුරුට්ට අපිට byproduct විදිහට ගන්න පුළුවන්. As well as during splitting the nut or the kernel. So inside the nut the coconut water is available. So here the coconut water is another important byproduct. Then the pairings fall into the flow removed from the grind prior to oil extraction. Later we will discuss these steps. So here you can see, as I mentioned earlier, normally the woman involved with this pairing process, removing the testa. Here you can see the brown color testa. So this is the knife, pairing knife we use to remove this testa. Then this testa, removed testa, we can use for oil extraction process because this testa also contain oil as well as important vitamins also available. So therefore we do not remove them as a waste. We use testa to extract oil. අපි මේ testa එකෙන් ගන්න oil එකේ brown color එකක් තියෙනවා. මොකද testa එකේ color එක නිසා, but it also very good oil source as well as rich in vitamins also. Then the next step is washing, inspection, and also the trimming. So the washing means now we have to wash them carefully. Okay, then as I mentioned earlier, this is a very hygienic process. Therefore, we have to wash them now. This is the washing step. Then as well as we have to inspect again, and also the trimming. Trimming means we cut the paired kernel into small parts. So paired kernel is washed manually. This is done by chlorinated water, not the normal water. We use chlorinated water for washing purpose. As well as here in this picture also you can see there is a series of washing tank. Not only the one tank, there are series of washing tank. It means in the first tank they wash kernel, then the washed kernel put into the second tank. So here again wash and put in the third tank. Likewise, series. So the kernel pass through this series of washing tanks. Washing tanks contain chlorinated water. So these tanks are fabricated either from the galvanized metal or the stainless steel. So I guess you can see these pictures also. These tanks, the washing tanks, are fabricated either the galvanized metal or the stainless steel. We do not use the plastic or any other materials to build these tanks, because if you use those things, especially without the stainless steel or without galvanized, if we use just metal, අපි නිකන් යකඩ ටැංකියක් විතරක් පාවිච්චි කරොත්, so the kernel may be infected by the impurities. මේ යකඩවල තියෙන දේවල් වලින් මේ අපේ kernels damage වෙන්න පුළුවන්, infect වෙන්න පුළුවන්. Therefore we use this galvanized metal or stainless steel for this producing these tanks. Here in this picture you can see these tanks. So at the end of the washing sequence, the kernel is inspected. So after completing the washing step, now the kernels we should inspect. So we should inspect the kernels. So during the inspection process, we can remove any if there is any remaining tester. So now we can remove RP pairing remove කරද්දී tester එක ඉවත් කරලා නැතුව තව පොඩි පොඩි තියෙන්න පුළුවන්. So now this is the step we can remove the any excess tester. Then the trim to the removed blemishes and also the traces of the remaining tester, and cut into the 3 section prior to transfer into the final wash tank. So now we have to cut the paired kernel into 3 portion or the 3 sections, then again put into the final washing tank. Then the blanching, this is the next step. So it means we immerse or we dip the paired as well as the cutted kernel into the boiling water. This is the blanching. So in this boiled water, the temperature is around higher than the 9 to 5 Celsius, as well as a time. So normally we immerse or we dip the kernel around 90 seconds to complete the blanching. So blanching also an important process to remove or to destroy any kind of bacteria or diseases or any impurities attached with the kernel. So blanching also now used. Then අපි chlorine water වලින් හේදුවා. then මෙතන ආයි temperature එක වැඩි hot water වල දාලා අපි wash කරනවා. එතකොට තවත් ඉන්නවා නම් මොන හරි bacteria හරි diseases ඉන්නවා නම් ඒවා remove කරන්න පුළුවන්. So here you can see the wire bucket we use this purpose, as well as now here you can see this kernel now cut into the 3 parts. So during the blanching, the kernel is loaded manually to the feeding hopper. So after completing the blanching or hot water treatment, now we can load the coconut or kernel into the feed hopper. So the feed hopper connect with the conveyor, and the conveyor, at the end of the conveyor there is a drying section is started. So the loaded kernel are transported by conveyor. Here you can see the conveyor. We feed our blanch kernel into this hopper, and there is a conveyor. So using this conveyor is, here you can see the kernel now moving into the drying section. So then the disintegration means every component of the disintegrator is made out of stainless steel. Here you can see from here every part is, as well as the drying chamber also made out of stainless steel to avoid unnecessary damage of the kernel. Then the kernel is transported by the blancher conveyor into inlet hopper to disintegrator feed conveyor. The kernel is rapidly disintegrated due to the action of the centrifuge motion. So disintegration means so if there is any other water or the moisture, then during the disintegration, removing those water. So it will facilitate the drying purpose. So the drying use a tray dryers, or this is a semi-automated dryers. The temperature we use for 80 to 105. This is the temperature range. And the time, normally it will take 45 to 65 minutes. Then normally the drying, we use dryers. So the capacity of the dryers are vary. So normally as an average per hour, so normal capacity dryer, normal size dryer can dry around 50 to 80 kilograms of kernels. Then the kernel is cooled before shifting. So now after around 1 hour period, all the extra moisture is evaporated, and now our dried kernel, now we can shift. Shifting means we can separate them according to the size. So this is the shifting process. Classification dried kernel according to the size. So this is the next step. So the desiccated coconut we can separate, or we can categorize according to the size, because it depends on the size or the grade of the coconut, as well as the what you call the tea processing. Also there's a shifting process at the end before the packing. According to the size, we can shift, we can separate them. So likewise here also the shifting step. So normally medium, fine, clips, flakes, and so the shaded, like there are several grades available according to the customer requirement. We can divide the final product. So here you can see the shading machines. So there's a net, and according to the net size, we can determine the size of the final product. So finally, the packing and also the export. So this is the final step of DC manufacturing. So shifted desiccated pack in fitted with the high density polythene liner. So here you can see the photograph. So in here there is a high density polythene liner available. So not just a paper bag. So inside the paper bag there is a high density polythene liner. So what is the importance of using or applying this polythene? Why we use polythene? Is it a compulsory thing? What do you think?
වාතය ඇතුළේ නතර කර
Yes, that is the answer. So to make airtight conditions, as well as to avoid the moisture absorption, අපි මේක අපි export කරන්න ඕනේ, සහ we have to keep this bagged for longer time in a storage conditions. So under that conditions, sometime the moisture may be absorbed inside the bag. To avoid that, we use this polythene. අපි වාතය ඇතුල් වෙන එක සහ ජල වාෂ්ප, ජලය උරා ගන්න එක වළක්ව ගන්න තමයි අපි use කරන්නේ polythene line එකක් ඇතුළට දාන්නේ නිසායි, as well as to keep quality without any defections. So normally, according to the buyer requirement, we can determine the capacity of this bag. Sometimes 50 kilograms, 25 kilograms, or 12.5 kilograms. Likewise, capacity may be vary. And prior to filling, bags are labeled. Here in this picture, so you can see the country of origin, fill on. The DC product grades we can identify, and the mill number also we can identify. as well as the weight here. The cross weight is 50.7 kilograms net weight. So likewise, date of manufacture, code of shipper, government order number. So likewise, those are the informations available or the printed on the bag. Okay, then there are some quality control method or quality control practices are available during the production. So the sensory evaluation is one of them. So simple and inexpensive thing, subject and based on the experience. So during the sensory evaluation, we test the taste, smell, visual, or the appearance, and also the feel. So these are the some physical properties, some the chemical properties we use to test during the sensory evaluation process. We should test the taste. So the desiccated coconut has its unique taste as well as the smell. So visual color should be a white color. If it appear yellow color, it means it's a quality damage. And also the feel. හොඳට වියලිලා තියෙන තත්ත්වයක් තියෙනවා නේ ගොඩක් තෙතට තියෙනවා නම් ඒ කියන්නේ ඒක ප්‍රොඩක්ට් එක හොඳ නැහැ. So these are some defects of processed DC. So sometime we can feel some sloppy flavor. අපිට සමහර වෙලාවක මේක නිකන් සබන් රහක් එන්න පුළුවන්. desiccated coconut වල හා සබන් රහක් එන්න පුළුවන්. as well as the off odors. pleasant smell එකක් නැතුව නිකන් නරක් වෙච්ච ගඳක් එන්න පුළුවන්. as well as the greasy feeling. So greasy feel means so if we touch it and we can feel like greasy or the oil feeling. නිකන් ඇලෙන සුළු බවක්. as well as a discoloration. So normally it should be in a white color, but sometimes the yellow or the off-white color, like discoloration may be happen. There are several reasons for these defects, so the sloppy flavor of water. So especially the improper storage conditions as well as the improper practices during the manufacturing process. If we do not use the matured coconut, or sometimes we do not follow the proper hygienic conditions throughout the process, as well as the drying is not completed in a proper temperature and also the optimum time period, as well as after processing also. Sometimes we store those bags in a very the conditions also may in conditions, especially the moisture condition, or if we store the bags in the high moisture environment, so moisture may be absorbed. So those are the things. ඒ වගේම අපි දැන් මේ බෑග් ස්ටෝර් කරලා තියෙනකොට ඒ බෑග් එකට උඩම දාලා අපි ලොකු අපි කියන්නේ අට්ටියක් ගහනවා කියලානේ. ඒ වගේ ගොඩක් තියෙනකොට සමහර විට due to the pressure. So if we store the bag one by one, so likewise due to the high weight, the quality of the desiccated coconut may be reduced. So likewise, these defects happen during the production as well as during the storage period. These defects may be happen. Okay, then the uses of the desiccated coconut we use for the bakery industry, especially to enhance the texture, flavor, aroma, as well as the eye appeal of the food as a toppings or the fillers. We use desiccated coconut. සමහරට ඔයාලා දැක්කත් පොඩි cakes වල සහ toffee වල මේ desiccated coconut දාලා තියෙනවා as a filling material as well as a toppings. As well as we use this as an ingredient for the baking of biscuits, snack bars, the cakes or the cookies. So there are various products use desiccated coconut as ingredient. Here in this picture you can see the chocolates and sweet items, toffee, cake. So what products are available with the desiccated coconuts. Okay, so during the desiccated coconut production, these byproducts, especially the pairings, during the pairings, we remove testa. During the dehusking, we remove husk, and also the wash water, coconut shell, also we remove during the process. We do not use them, but they don't do not we do not consider them as waste because there are some other useful uses. We can obtain the oil, we can obtain husk fiber and coir pit, we can obtain the charcoal using those products. Okay, especially during the production for the drying purpose, we need the high amount of temperatured air, the hot air. To produce hot air, we can use this coconut shell or the coconut husks as a fuel material. අපිට desiccated coconut dry කරන්න අවශ්‍ය කරන hot air. Celsius 95ට වඩා ඉහළ උෂ්ණත්වයක තියෙන hot air අවශ්‍යයි. ඒතර hot air generate කරන්න අපිට මේ base අපිට මෙතන මේ bioproducts විදිහට පාවිච්චි කරන coconut husk, coconut shell පාවිච්චි කරන්න පුළුවන් factory එක production එකටම පාවිච්චි කරන්න පුළුවන්. Okay, that's all about the desiccated coconut production. Any question, any thing do you want to clarify? I briefly explain the production process because I do not go more deeply with the time limit. Also, we have another products also we have to discuss. Any question? Okay, then I will move to the next product. As last week, I will share this presentation with you, and you can read them again. Then the copra processing. So copra processing, again, there are copra also two types, edible copra as well as a non-edible copra. So the non-edible copra, are we producing non-edible copra? Yes, actually. Sometimes the copra we produce as a fuel. අපි copra පාවිච්චි කරනවා නිකන් ගිනි අවුල ගන්න fuel material activator. So that's a non-edible copra. So now I'm going to discuss about the edible copra production. So edible copra is available into two different forms, ball copra as well as the cup copra. There are two types of copra, edible copra. Ball copra means fully matured whole unsplit nuts. So the main difference between the ball and cup copra is ball copra we use unsplit nuts. අපි kernel එක දෙකට පලන්නේ නැහැ. සම්පූර්ණ එක ball එකක් විදිහට තියෙනවා. So the cup copra means we split or we separate the kernel into two parts. So especially during after the dehusking process, dehusked nut is split into two halves. අපි ball copra හදනකොට අපි පොල් ගෙඩිය දෙකට බිඳින්නේ නැහැ. එක අවස්ථාවකවත්, but cup copra හදද්දී අපි පොල් එළිය ගැහුවට පස්සේ පොල් ගෙඩිය දෙකට පලනවා. So that's the major difference between ball copra and cup copra. Okay, then the ball copra manufacturing. So unhusked nuts are stored for about 8 to 12 months on a raised platform, usually made of bamboos. We use bamboos to build this platform. So on this platform, we store our unhusked nuts. Unhusked means at that level, we remove the husk. So that unhusked nuts, we can store around 8 to 12, means near to 1 year. 1 year period, we have to store in a raised platform එකක් ගබඩා කරලා තියෙනවා. As well as inside the shade, because we have to protect these nuts from the rain. Therefore, we have to keep inside the shade, as well as the high sunlight. So during this 1 year period, so what happened? Coconut water slowly get absorbed. අවදාන යාළුවල ගොඩක් කාලයක් අපි පොල් ගෙඩියක් තිබ්බොත් ඒක එන්න වේලා මොකද වෙන්නේ? අර ඇතුලේ තියෙන වතුර පස්සේ නැතු වෙනවනේ. අපි දැන් සාමාන්‍ය පොල් ගෙඩියක් වලට වතුර හෙලන සද්දයක් එනවනේ. ඒකට කාලයත් එක්කලා මේ තියෙන වතුර ටික පොල් ගෙඩියටම ඇබ්සෝබ් කරගන්නවා. කර්නල් එකටම ඇබ්සෝබ් කරගෙන ඒතකොට ඇතුලේ වතුර හැවෙන්නේ නැහැ. ඒකට අපි කියනවා සාමාන්‍ය වතුර හැවෙන්නේ නැතුනහම මේක කොප්පරා වෙලා කියලානේ. So likewise during that time period, all the water now get absorbed into the kernel, and the kernel dries out. The kernel also, so the excess water evaporate, and kernel also getting dry, and the kernel losing itself from the shell and rattles when shaken, as well as after certain time period, now kernel itself detach from the shell. Shell එකෙන් kernel එක ගැලවෙනවා. So at that time, if we shake a nut, so what we can hear a rattle sound. The rattle sound means inside the nut. Now we can hear the kernel is moving here and there because the kernel and the shell is now detached. We can hear the rattle sound. So the nuts at this stage is dehusked. Okay, now it's the time for dehusk. Okay, then now we can start the dehusk. So the shell carefully removed to separate the whole dry kernel or the ball. Okay, now we can now at that stage dehusk stage එක වෙනකොට dehusk වෙලා තියෙන්නේ. So the shell carefully removed to separate the whole dry kernel. Okay, now then after 1 year or the 8 to 12 months, now we can start the first practice. We can remove the shell because the husk is already removed. Now we can start to remove the shell, or we can separate the shell and dry kernel. Drying process can be accelerated by occasional heating of nuts by a slow fire set under the platform. Okay, so normally this drying process or the storage period is around 8 to 12 months, but we can reduce the time period by applying heat. So we can use heat to rapid drying to achieve the rapid drying process. Okay, so these are the final products. So after de-shelling or removing shell, we can get the round ball copra. මේ විදිහට මාස 8-12 ගියාට පස්සේ අපිට shell එක අයින් කරාට පස්සේ මේ විදිහට ගන්න පුළුවන් copra එක. So this ball copra is soft, sweet, oiled as well as a creamy color. So මේ final product වෙනකම් මේක අපි open කරලා නැහැ. ඒ නිසා soft ඒ වගේම sweet එකත් වැඩි because all the coconut water absorbed into the kernel as well as the kernel excess water also evaporated, therefore the sweet percentage is high, as well as the oil content also very high, cream in color. So this copra is consumed with the sugar or made into chips for manufacturing sweets. And so as gold copra is also used for religious and also the cultural ceremonies, as well as for the traditional medicines use copra. In Sri Lanka, the limited quantities of the edible white copra is made from export at a very high premium. Now we can use this copra for extract oil. Coconut oil extract කරන්න අපිට පාවිච්චි කරන්න පුළුවන්, or if you can use for any other purposes. There are several purposes for manufacturing food items or other for the medicines also we use. Likewise, we can use the oil yield of the tall palm copra under rain-fed condition is around 1.7 to 2 tons per hectare. This is per hectare. So normally per hectare we can obtain around 1.7 to 2 tons of oil using the copra. This value is from the tall palms, but this value is different from tall palm to dwarf palm. Okay, then the processing of milling copra. So normally, this is the whole copra production. Let's see how the copra is produced during the milling or the factory stage. So these are the steps. First we dehusk, then the split. Okay, then now after dehusking, now we split the nut. So what happened in this stage? Then the split කාට පස්සේ මෙතනින් බෝල් කෝප් එකක් නෙමෙයි හම්බ වෙන්නේ අපිට කප් කෝප් නේ. ඒකට කෝප් එකෙන් කොටස් දෙකක් තමයි හම්බ වෙන්නේ නට් එකේ. Then the stacking on the platform. Okay, now like the previous stage, previous processing steps, we do not keep this nut for 8 to 12 months for reattaching the kernel and shell. So what we do here, we first do the sun drying, then we store on a platform, because here also we have to remove the shell and the kernel. To facilitate the shell and kernel, we have to dry it. So this process is done on this platform. Then firing means to apply that necessary heat. We can use fire. Then after certain time period, certain firing. then මේ අපි firing කරන එකත් කොච්චර වෙලාවක් අපි heat එක දෙනවද කියන එක time period එක determine කරනවා අපි apply කරන heat එකේ තියෙන temperature එක as well as the weather conditions. Now we can easily remove the kernel from the shell. Then the removing shell, then the sorting for storage. So likewise, finally the quality copra we can know. So this is the normally practice happen in a normally manufacturing process. Most of the time, Sri Lanka, we do not produce the ball copra. We do this cup copra production. Processor good loku කාලයක් ගත වෙනවා. මේ process එකට ඉක්මනින් අපිට dry කරලා kernel එක ඉක්මනින් shell එකෙන් remove කරන්න පුළුවන්. Therefore we use this process. Okay, so in this chart you can see this cup copra production, harvest nata, heat, husking and transporting, splitting, sun drying. So during the sun drying period, we can allow the splitted nuts to drain off the excess water. Then place on the platform, fire setting, unloading, grading, sorting, and the packing. So these are the steps. Okay, so dehusking. Here we can remove the fibrous outer layer or the husks. So here you can see wooden spike we use for dehusking. The wooden spike with the sharp iron tip using dehusking machines. So we can use the dehusking machine mechanically. An experienced worker can dehusk about 1,500 to 2,000 nuts per day. So normally per day, experience ඔයාලට මෙතන experience එකක් තියෙන හොඳට මේක කරන්න පුළුවන් experience work කෙනෙකුට සාමාන්‍යයෙන් පොල් වලදී 1500ක 2000ක වගේ පොල් පිළි ප්‍රමාණයක ලෙලි අයින් කිරීමේ ස්පීඩ් එකක් තියෙනවා. So mechanical dehusker normally can using a dehusking machine. He can dehusk around 950 to 1,000 nuts per 8-hour periods. Then the splitting. Nuts are split into hulls by stitching with a heavy knife or a small axe we can use for this purpose, like this. The water inside the nut is drained off and the hulls or cups are ready for drying. Here again the water we can use for other products. A skilled worker can split up to 7,000 nuts a day. So for getting good quality copra, it is important that the split nuts are taken for drying within 4 hours. So immediately after splitting nuts, we have to start the drying. If not, it will affect to the quality of the copra. වතුර තියෙනවා ඉවන් කරන්න ඕන අපි ඩ්‍රයින් කර වටන් ගන්න ඕනේ එහෙම නැත්නම් එහෙම moisture content may be increased and the copra quality will be getting reduced. So split nuts are kept in inward position for around 1 to 2 hours under sun. So the first drying we should do under sun drying conditions. So during this period, drain out the nut water completely. So inward position means upside down up here. උඩට මාරු කරලා open area එක ඊට වැටෙන විදිහට තියන්න ඕනේ. Delay of more than 4 hours before drying encourage the bacteria and the deterioration of the products. Then the copra drying. In the process of drying, the surface moisture in the exposed portion of the split that is rapidly lost. So final moisture content of the copra should be around 6%. So up to reduce 6%, we have to dry the copra. So there are several drying methods available. Sun drying. So small coconut holders in house scale level also we can practice the sun drying. But you know, the sun drying depend on the amount of sun level as well as the weather. If it is a rainy period, so we can do not practice the sun drying. As well as smoke cleanse method also we can use. As I mentioned, as I shown in the previous picture, we can set the fire and we can do the drying. And also there are some dryers also available, hot air dryers, like most of the time we can use them. So we compare to the sun drying or the smoke drying, the hot air drying method. If we use hot air drying method, we can obtain a good quality copra. So this is the sun drying step. So the copra, now we have placed the position. Most popular and the simplest method of copra making, cups are laid out in a jar to the open area. Open side turn to the sun. So after about 2 days of drying, the kernel or the meat gets detached from the shell. So if you use the sun drying method, it will take around 2 days for complete drying. Complete drying means to reduce the moisture level up to 6%. Then we can remove the kernel and the shell. The partially dried kernel is the scoop out by means of thin wooden lever. Now we can, after 2 days, now we can easily remove the kernel using a scoop or it's using a wooden lever. අපිට පොඩි හැන්දක් නම් පතුරක් වගේ එකක් පාවිච්චි කරලා kernel එක shell එකෙන් අයින් කරන්න පුළුවන් in this method. So the detached kernel are again arrange the yard with the open side facing up for the further drying. So after removing the shell, again we have to dry this de-shelled kernel. The drying process has to be continued for further period of 4 to 5 days. 4 to 5 days we have to dry continuously. And copra should be covered during the night. So night time we should cover the copra with a open කරලා තිබොත් තියෙන moisture absorb කරන්න පුළුවන්. නිසා රාත්‍රී කාලයේදී මේක වහන්න ඕනේ. So you can imagine that this is very difficult in the rainy season. So continuous sun drying should be done by obtaining good quality copra. So without breaking, or we should supply sunlight to get the quality copra. So as I mentioned earlier, if the rain happen, the production quality produce poor quality copra as well as moldy or mold can push වගේ දේවල් ඇති වෙන්න පුළුවන්, as well as the discolored copra are produced due to the rain. So the second drying method is smoke method, drying by direct heating kilns. So kilns can නිකන් උතුණක් වගේ පාවිච්චි කරන්නේ. Here you can see this is the wooden platform. So we place copra on this wooden platform and we set the fire at the bottom. So for that, the fire purpose, we can use the coconut shell or the coconut huts to set the fire. So now the hot air goes through these nuts kernel and remove the water. Hot air together with the produced combustion pass through the cup. So here during this firing, some smoke also produced. Those smoke also pass through these nuts. So especially the smoke particles, the combustion particles are help to avoid the development of diseases, especially the fungus or bacteria. I mean, දුම යන නිසා දුම් වලින් දිලීර බැක්ටීරියා හැදෙන එක නතර වෙනවා. එතන normally දැන් ගොඩක් දුම් වල වේලනවානේ අපි. පොල් විතරක් නෙමෙයි, සමහරට මස් වගේ දේවල් වලත් මස් කාරවල ඒවත් අපි දුමේ වේලනවා කියලා කියන්නේ. ඒකට මේ දුමේ වේලදී මේ දුම් වල තියෙන මේ සංයෝග නිසා bacteria දීල වතන එක නතර වෙනවා. So this advantage is there. ඒ advantage එක මෙතනක් තියෙනවා. So this is the modern copra drying method. So the modern dryer coconut cups can be converted into copra into 16 to 32 hours even during the rainy season. So this is these are the advantages. So we can get the copra within 2 days. After දවස් දෙකකින් කරලා copra ගන්න පුළුවන්. As well as we can practice this method in the rainy season also. So these are the advantages of modern copra dryers. So in these dryers, the heat generated by the burning coconut shell and other palm waste is used to dry raw coconut cups into copra. To produce heat, we can use coconut shell or any other fuel material. The copra produced is of high quality, which gets premium price than the already sun dried or the cleansed dried copra, because in here we can control the temperature level, amount, as well as we can control the other conditions to get the quality copra. Therefore, the price of those kind of copra also very high. We can avoid the deterioration or decolorations using this modern drying method. Then storage of copra. After producing the copra, we can stack in the gunny bags in the airtight room, because you know the copra or the coconut contain high amount of lipids. So lipids can easily attacked by bacteria. මේවා ලිපිඩ ඉක්මනින්ම fatty acid තියෙන නිසා ඉක්මනින්ම මේවා oxygen එක්ක සම්බන්ධ වුනහම after reaction of the oxygens, so it can deteriorate. Therefore, we have to store those products in airtight conditions. දැන් ඔයාලා දන්නවා ගෙදර තියෙන පොල් ගෙඩියක් වුණා ටික කාලයක් යනකොට ටික කාලයක් කියන්නේ පැය කිහිපයක් යනකොට ඒක සමහර වෙලාවට මේ නරක් වෙනවානේ. පොල් තෙලුත් එහෙමයිනේ ඉක්මනින් ඒවා මුඩු වෙන්න බලනවා. So therefore, the main reason is the fatty acid. So sulfuring also we can do to avoid those deterioration. So we can apply the sulfur dioxide, because the sulfur, we use sulfur as a fungicide also, especially to control the fungus. Therefore, we can use the recommended amount of sulfur dioxide. So the deterioration of copra, so especially a defective method of processing and a high moisture content are the major factors of deterioration of copra. Sometimes the drying temperature may be not sufficient, as well as drying period may sufficient. Therefore, the moisture content may be high. So normally the moisture condition should be less than 6. So if the moisture content is higher than that amount, it means that copra may be damaged during the storage period. So during the initial stage of the processing, also some deterioration may happen during the removing of the shell or the handling also. Those things may be happen. Sometimes the damage or spoiled coconut kernel may be mixed with the quality kernel. So likewise, processing also, we should be careful. And the bacteria multiply rapidly at the 80% relative humidity and the temperature less than 30%. Therefore, during the storage period, we have to ensure that the relative humidity ආර්ද්‍රතාවය 80 වඩා අඩුවෙන් තියෙන්න ඕනේ, as well as the temperature also higher than the 30. If not, that the temperature and the relative humidity is the optimum for bacteria growth. So we have to avoid those, or we have to control those conditions. So due to overloading of copra in the drying chamber, reddish coloration could be occur. So we can't load all the copra on the drying chamber the one time. So what happens if we do that kind of practice? All the smoke and all the heat do not pass through the copra properly. Therefore, the reddish coloration or the decoloration may be happen due to that practice. Okay, so those are the reasons for the decolorations, and by avoiding those processing as well as the storages conditions, by controlling them, we can obtain the good quality copra. So copra we can use for producing oil and any other products. Okay, that's all about the copra productions. So now we can produce oil using copra. Let's discuss the oil production. So the coconut oil, Sri Lanka, mainly coconut oil we produce using the coconut copra, the under temperature 70 to 75 Celsius using screw press. Normally we use copra as feedstock or the feeding material for producing copra. The temperature is 70 to 75, and we press the copra in a higher pressure to remove the oil. So the tropical world consumes as a primary source of fat, widely used in food and beverage, as well as other food products, as well as the beauty products. We use coconut oil. So the coconut oil contains the lowest level of unsaturated fatty acids. So the saturated fatty acid, it's not good for human health, but the unsaturated fatty acid good for human health. So among all other vegetable oil, coconut oil contains the lowest level of the unsaturated fatty acid. Therefore, it's very good for human health. So coconut oil also contains a range of useful characteristics, including low melting temperature, resistant to oxidative rancidity, good flavor, and also good aroma. So these are the characters or the qualities of coconut oil. So that's why the coconut oil is most popular in most countries as a cooking oil, as ingredient for other food products. So these are the top producers of coconut oil: Philippines, Malaysia, Indonesia, and Vietnam. Okay, then අපිට මෙතන බලහම අපි මේ top producers ලා අතරට නැහැනේ coconut oil. If you remember, as I mentioned earlier, we can't actually complete our national oil production. අපිට අපේ national production එකවත් achieve කරන්න තරම් coconut production එක නැහැ. මොකද we consume a high amount of coconut for our day-to-day life. අපි හැම කෑමකටම ගොඩක් වෙලාවට coconut පාවිච්චි කරනවානේ. ඒ නිසා අපිට export කරන්න වෙන ප්‍රමාණයක් නැහැ අපිට import කරන්න තමයි වෙන්නේ මදි ප්‍රමාණය. So top exporters of the coconut oil: Philippines, Indonesia, Malaysia, Thailand. And so in here you can see Sri Lanka as the 8th place. So some amount of coconut there are some factories, they are exporting coconut oil as a virgin coconut oil, extra virgin coconut oil, likewise. So normally per year we export around 1,520 metric tons of coconut oil, but compared with the production, the value is very low. Here you can see the Philippines, they export more than 8 lakhs metric tons, but we could export only 1,500 metric tons. Okay, then using this chart, I will explain the manufacturing processes of the coconut oil. Now we have coconut copra. I discussed how to produce copra. Then this coconut copra, drying, again we have to dry using a dryer at the temperature 60 to 70 Celsius. Then pressing of the coconut copra. Now using the higher pressure, we press the coconut copra. So during this step, we can obtain two products. The first one is the crude coconut oil. Crude coconut oil means coconut oil and other liquid parts. Sometimes the moisture may contain in the coconut oil. The solid part or the hunak we can obtain during this pressing stage. Then the crude coconut oil we have to filter to remove the fine solid particles and any other unwanted materials. So by a filter, we can remove the residuals here. Then the filtered liquid part we call as coconut oil. Then the coconut oil we can storage in large tanks for further uses. So this is the steps of manufacturing of coconut oil. So here you can see, normally to the production of coconut oil, we dry the coconut copra at the temperature of 60 to 70 Celsius. So less than the 100 Celsius. Then I think you may heard about the virgin coconut oil. So what is the difference between the virgin coconut oil and the coconut oil? What do you think?
සුදු පොල් තෙල්
Not sure. සුදු පොල් තෙල් කියන්නේ අපි white coconut oil. Virgin නේ. Okay, then I will explain it. So normally the virgin coconut oil, so we do not apply the heat here. අපි දැන් කලින් try කරනවා කෝප්ප but මෙතෙන්දී අපි dry එකක් කරන්නේ නැහැ dry කරන්නේ නැහැ. So the virgin coconut oil is produced using the white kernel of the coconut, although there are two methods of producing virgin coconut. Traditional method using coconut milk. So we can obtain coconut oil from the coconut milk. අපි ඉස්සලාම් පොල් කිරි වලින් milk වලින් අපිට හදන්න පුළුවන්. As well as wet process extraction. So the second method is wet process extraction. So in the Sri Lankan virgin coconut oil manufacturers follow this wet process. I will show you again a small video clip. It will explain the virgin coconut oil production. You can get more idea. As well as this video is in Sinhala language. I think most of you can understand it. By the way, you can see some subtitles in English, therefore it's no problem with the Tamil or Tamil students also. Okay, I think you can see my screen. මම වීඩියෝ ෂෙයාර් කරලා පේනව නේද? ඔව් සර් පේනවා. Okay, good. So here the nabul කියලා කියන virgin කියන එකට සිංහල convert කරනවා තමයි nabul කියන්නේ. So the nabul polythene means virgin coconut oil.
ආයුබෝවන් මේ නෑබුල් පොල් තෙල් නිෂ්පාදන ක්‍රියාවලියයි. පළමුව සිදු කෙරෙන්නේ පොල් එකතු කර ගැනීමයි. දෙවනුව මෙවැනි ආකාරයේ නුසුදුසු පොල් ඉවත් කර ගැනීම සිදුවේ. ඊට හේතුව මුළු නිෂ්පාදන ක්‍රියාවලියම අඩු උෂ්ණත්වයක් යටතේ සිදු කිරීමයි. මින්පසු පොල් කට්ට බිඳ දමා පොල් මදේ ලබා ගැනේ. ඉන් අනතුරුව ප්‍රයෝජනවත් නැති මේද සහිත කුරුට්ට රැහීම සිදු කෙරේ. කුරුට්ට සහිතව මේ ක්‍රියාවලියම සිදු කළ හැකි අතර එය නෑඹුල් පොල් තෙල් වලට වඩා ගුණයෙන් දෙවැනි වේ. කුරුට්ට ඉවත් කර ලබාගත් සුදු පොල් මද මෙම යන්ත්‍රයෙන් සිහින්ව කැබලි කෙරේ. එය පොල්වල තෙතමනේ ඉවත් කිරීමේදී පහසුවක් වේ. සිහින්ව ගාගත් පොල් වියලුම් යන්ත්‍ර තුළ සෙල්සියස් අංශක 55ට අඩු උෂ්ණත්වය යටතේ තෙතමනේ ඉවත් කර ගැනීම සිදුවේ. ඉන්පසු වියලුම් පොල් කෝල් ප්‍රෙස් එක්ස්පෙලර් නැමැති විශේෂ ඇඹරුම් යන්ත්‍රයේ ක්‍රමානුකූලව අඹරා ගැනේ. මෙම ඉවතට එන ඔයිල් කේක් මගින් බිස්කට්, අතුරුපස කේක් ආදී බේකරි නිෂ්පාදන සෑදීමට භාවිතා කෙරේ. පළමුවරට ලැබෙන අද්‍රාව්‍ය කුඩා පොල් අංශු සහිත නැවුම් පොල් තෙල් සුදු පැහැයක් ගනී. අවසාන වශයෙන් එම කුඩා අංශුද මෙම ප්ලේට් සහිත ෆිල්ටර් යන්ත්‍රයෙන් පෙරාගෙන පිරිසිදු ජලය මෙන් පැහැදිලි පෝෂණ ගුණ ආරක්ෂා කරගත් නෑඹුල් පොල් තෙල් ලබා ගැනේ. Okay, then I think now you have a clear idea about
the virgin coconut oil production. I will explain again. Okay, so in this flowchart, you can see here the production steps. First, the dehusking, deshelling, pairing, the blanching, as well as the draining or the removing water and desiccation. Those things are same as the desiccated coconut manufacturing. Then the milk extraction and also drying. So for the milk extraction, the milk method, we can use the milk extraction. We can extract the milk. Then the drying. We can desiccate the coconut. Then the centrifugation, the filtration, and finally virgin coconut oil production. So normally what happen here, we normally we dry the coconut under the low temperature less than 55 Celsius. But in the normal coconut oil production, we apply the temperature around 60 Celsius, but here at the low temperature. And the next step is we should press the kernel to remove the solid part and liquid part. So the solid part we can obtain same as the punak, but here we use that solid part for producing biscuit like food items. The liquid part, it contains some impurities or some solid particles, so we have to filter it again. During the filtering process, finally we can obtain the virgin coconut oil. So virgin coconut oil also, there are so many health benefits as well as a higher demand for the virgin coconut oil. Okay, then the production of coconut vinegar. Up to now, we discussed about what are the products we can obtain from coconut kernel. The kernel again the products So now onwards we will discuss the coconut water and sap-based products. The first one is coconut vinegar. So normally coconut vinegar is made from the sap or toddy of the unopened coconut flower. So I'm not discussing about how to tap coconut flower, coconut influences. So normally the unopened coconut flower, there are several methods. අපි පොල් මල පදම් කරනවා කියනවා මල සුදුසු තත්ත්වයට we have to convert the coconut flower to suitable for the tapping. Tap කරනවා කියලා තමයි කියන්නේ making sap එක ගන්නවට. So there is another process, but I am not going to discuss it. So what we do here, we can obtain the coconut sap from the coconut flower. Then the coconut water or the sap fermented or as well as we can obtain the coconut water also producing vinegar. අපිට sap එකෙන් හදන්න පුළුවන්, පොල් වතුරෙන් හදන්න පුළුවන්. Use to produce the vinegar using vinegar generators. Coconut water is highly being washed in copra and BC industry during the production process I discussed. So most of the time coconut water do not use for further processing. Therefore, we can use those coconut water for producing vinegar. So extensively used as a preservative and also the flavoring agent for the cooking purposes and to produce a chutney like food item. We use vinegar as preservative agent.
Miss.
Yes. Hello.
Miss hadan acharu.
Yes, pickles, salads, sauce, and many other condiments. we can produce using vinegar as a preservative agent. කල් තබා ගන්න පුළුවන් ද්‍රවයක් විදිහට පාවිච්චි කරන්න පුළුවන්. So the coconut water consists of 3 to 4% of sugar. Therefore, we can use the producing vinegar as well as the low cost product. So vinegar also has several health benefits, help in digestion and improve the quality of the cooked meat and fish. මස් මාළු වගේ දේවල් හදද්දිත් අපි විනේගර් පාවිච්චි කරනවා. So this is the processing of vinegar. Here you can see the material or the raw material is the coconut water. So coconut water we mix with the sugar, then the pasteurization. Pasteurization means we apply the heat around 5 minutes to remove any unwanted bacteria or any microbes. Then the keeping for the cool. After pasteurization, we keep some time for reducing the temperature or getting cool. Then the addition of yeast. So here during the pasteurization, we remove the microbes. Now what we do, we purposely now add microbes. Here we add Saccharomyces or the yeast. So half teaspoon of yeast we add. Then alcoholic fermentation is take place about 1 week period. Yeast දැම්මට පස්සේ මෙතන පැසීම සිද්ධ වෙනවා about 1 week. Then time to time we have to stir or we have to mix it properly. Then again the heating. We should avoid the further fermentation. Therefore, we can apply the heat. Then the grain cooling. After that, we can add the vinegar inoculums. Inoculums in අපි කියන්නේ culture එකක්. So we can add a culture contain the vinegar forming bacteria. Then again, them start their fermentation around 1 month period. So after the 1 month period, we can obtain the vinegar. So again, we have to do the pasteurization because we have to avoid the further fermentation. So again, the pasteurization, and finally we can store in a bottle. So this is the manufacturing steps. So using coconut oil, so finally use of the microbes, we can obtain the product called as vinegar. So here we use sugar as a sucrose source for these yeast and other microbes during during this process. අපි සීනි පාවිච්චි කරන්නේ මෙතන මේ ඉන්න microbes ට අවශ්‍ය කරන sugar ලබා දෙන්නනේ. දැන් අපි බලන්න අපි පාන් ආප්ප හදද්දී උනත් ඔයාලට experience තියෙනවා නම් අපි yeast එක්කලා පොඩි සීනි ප්‍රමාණයක් add කරනවා නැත්නම් coconut වතුර දානවා. Because coconut water also contains sucrose. Here we use sugar in this process. Okay, so the toddy production, I will briefly explain. The toddy production is a coconut sap obtained by tapping the unopened influences of the coconut palm. We can use this sap to produce the toddy. So major raw material for alcoholic beverage also the toddy. So the toddy, further fermentation, we can produce other alcoholic beverages. So the coconut sap browning clear liquid sucrose contain around 14 to 18%. So here you can see this is the inflorescence, unopened inflorescence. We before it open, you know, during inflorescence we discussed last time, it covered with the spade. අපි හනස්සකින් වැහිලා තමයි තියෙන්නේ මේ inflorescence එක. So මේ හනස්සෙන් එළියට එන්න කලින් inflorescence එක අපි මෙතන inflorescence එකෙන් මේ base එකෙන් අපි කපනවා. කපලා so we we tied a container here. Use a clay pot here. As well as there are some medicines also we used here to enhance the sap segregation. අපි බෙහෙත් බදිනවා කියලා කියන්නේ මල් වලට. So likewise, there are several steps are available. So the tapping normally we can do twice a day, 2 times per day. We can climb into the coconut plant and we can collect the sap. So harvesting of toddy can be done in the morning or in the afternoon. So there are differences between these two harvests. If we harvest sap in the morning, we should take it before 8 a.m. So that sap contain higher amount of sucrose. So therefore, that sap is best for producing toddy and vinegar, because that sap contain less amount of sucrose. Sucrose amount එක අඩු නිසා අපිට toddy and vinegar like fermented product we can obtain from morning harvest. So the afternoon harvest, so take not later than 3 p.m. Before 3 p.m. we can get another harvest. This afternoon harvest contain high amount of sucrose. Therefore, we can obtain the afternoon harvest for producing sweet products or non-fermented products like the trickles or the honey, jaggery. We can produce using afternoon harvest. So the resting period means after collecting sap, we have to avoid the further tapping of the plant. අපිට එක දිගටම ගහක් tap කරන්න බෑ. ටිකක් resting කාලයක් තියලා තමයි අපි tap කරන්නේ. So after 8 months of tapping, we have to keep the plant without tapping 4 months. So that time period we call as resting period. So the toddy we use to reduce the alcoholic beverages as well as to produce the vinegar. The quality of the vinegar is very high if we use toddy as raw material rather than the coconut water. Then the sweet toddy we use to produce jaggery or hakuru, as well as the kitul coconut honey, as well as we can drink the toddy as toddy. After toddy විදිහටම පාවිච්චි කරන්න consume කරන්න පුළුවන්. It contain කියලා හඳුන්වන්නේ some alcoholic materials. So that's all about the edible products. We discussed the kernel-based products as well as the sap-based products. Then now onwards, I will discuss what are the non-edible products. Non-edible products also again we can categorize into shell-based products and also the fiber-based products or the husk-based products. So I think I'm no need to discuss about the coconut shell-based products. So the charcoal and also the activated carbon and the ornamental products are the products we can produce using shell. Then I will briefly explain what are the products we can produce using coconut husks. So first I will discuss fiber products. So the coconut fiber is a natural fiber. So most of the time we prefer to use those natural fibers than the synthetic fibers. So in addition to coconut, what are the other natural fibers? So what are the other plants we can obtain natural fibers? Do you know them? Is that the coconut, only the coconut is producing the fiber? Whole කෙදි වලට අමතරව අපි මොනවද කෙදි ගන්න පාවිච්චි කරන අනිත් natural මොනවද plants? Same as the coconut, we can use the palmyra or we can use other palm family trees we can use to produce fiber, as well as we can use jute-like plant materials to produce fiber. So demand of natural fiber is increasing. Here in natural fibers, jute, coir, cotton also, plants we can obtain the natural fibers. So coir fiber is produced from the coconut husk. 10% from the total husk removed from the coconut industry is used for producing manufacturing coconut fiber. So now you can think the most of the coconut husks we do not use to produce fiber. Only the 10% we use, because most of the time we use coconut husks as a fuel material. So to obtain the heat or to obtain the fire, we use husks as a fuel material. The small amount of husks we use to produce fiber. So in this diagram, you can see the production steps. Again, dry husk, after that rating after certain time period, pass through the breaker drum, passing through the cleaner drums, like several drums are available. So these drums, during their rotation actions, so what happened, the fiber separate with the pith. So the fiber and pith are separating during passing through these cellular drums. So here the separation of coir pith, as well as according to our requirement, we can determine the size of the fiber. So for production of the mattress, we call that fiber as mattress fiber. So we can obtain mattress fibers, as well as the blister fiber. Blister fiber is different from the mattress fibers. Their sizes, their length are different. Then after that, we should dry them properly, and also the cleaning, as well as the boiling. Boiling also we can do. Bowl වගේ හදාන්න පුළුවන්, clean කරන්න පුළුවන්, as well as we can bleach them. So if we use the fiber for the ornamental products or producing brooms, so we can color them. So what we have to do, we should bleach them and we can color them. Then the grading, sorting. So these are other manufacturing steps. So normally coconut husk we should put into the drum, breaker drums, cleaner drums, like drums. So in here, what happened, the fiber is deattached with the coir pith. Then coir pith we pass through the coir pith manufacturing processes. The fiber we use to produce quality fiber using other steps. So normally the white fiber also available nowadays. This is limited to southern area and the Katunayaka area of Sri Lanka. So green amateur husks are used for producing white fiber. So it means the matured and dried coconut nuts are not suitable for producing white fiber. We use green immature husk. ගොඩක් අර අමු ගෙඩි තමයි අපි මේ white fiber ගන්නෙ. ඔයාලා දන්නවා පොල් ගෙඩියක් අපි අමු ගෙඩියක් තෙලි ගහුවාම මේකේ ඇතුලේ තියෙන මේ මෙසොකාප් එක සරමක් සුදු පාටයි. ගොඩක් වේලු එකක් ගත්තාම මේක fiber දුබුරු පාටයි. So we use the immature nuts, immature husks to produce fiber. White or the light brown in color, here you can see. Smoother and finer, but also weaker. So we compare to the mature husk, this immature husk fiber, the white fiber is very weak, because the percentage of the cutin and amount is very low, as well as smooth and finer. අර වගේ higher නැති fiber එකක් තමයි අපිට white fiber වලින් ගන්න පුළුවන් වෙන්නේ. So there are several uses of white fibers used to make yarn that is used to match all the ropes to produce mats and the ropes. So other coloring also very easy with this white fiber. Okay, then these are the different types of fibers: bristle fiber, mattress fiber, omat fiber, and coir twins. Like according to their size, their length, we can differentiate those fibers. So the blister fiber is thick, coarse, and also long. Kanakamiන් වැඩි දිගයි සහ කොරස් you can ටිකක් hard ගතියෙන් වැඩි. So the mattress fiber is very thin as well as the short fibers to produce the mattress. And the omat fiber removed fiber particles in the cleaning of the blister fiber. So during the blister fiber production, the very small fiber particles we known as the omat fiber. So there are several products or uses of the omat fibers also. Then the coir twins means separated coir sent through a machine and produce twin coir. So the small tiny particles we use to produce coir twins. So likewise, according to their size, we can categorize several type of fiber. Okay, so these are the coir-based products. So coir ropes, coir mats, mattress, as well as these kind of ornamental products also we can produce using coir. So in your home also you can identify several products produced using coir. Okay, I think that's all about the husk-based products. So in addition to that, we can use coir pith to produce substrate. I discussed earlier also. Coconut pith we can use to produce a growing media, different growing media. In that video clip also, I guess you noticed that as a planting material or as a growing media, we can use coir pith. Okay, then that's all about the products or the processing technologies of the coconut. Any question? Anything do you want to clarify?
Recording stopped.
Okay, so I think with that we have come to the end of this course module, commercial plantation crops. So what do you think about this course? මේ subject එක මොකද හිතෙන්නේ? So some of you have familiar with the tea. All of you may familiar with the coconut, but tea and rubber are new some students. What do you think? කොහොමද හිතෙන්නේ හොඳයිද? ඔයාලා idea එකක් ගත්තද? crop එක ගැන as well as the production technologies.
ටී රබ්බර් ගැන නම් ලොකුවටම පාඩම් පැහැදිලි වුණා. මදි ඇත්තටම පොළොන්නරුව අතර පැමිණි නිසා හොඳටම පැහැදිලි වුණා. ටී රබ්බර් තමයි පොඩ්ඩක් අමාරුනේ තේරුම් ගන්න.
Tea rubber. Okay. So I think actually these are normally in the university, these are the separate subject. But I think with your course module, with the given time period, we have try our best to cover the most important things. So you can study those subjects further if you're interested to involve with the degree program, I guess. So at the diploma stage, I think we try to do our best to get most important things to cover within this 2 hour or 3 hour period. As well as if you want, I will share some of the reading materials to your LMS. So I guess all of you have the LMS access. Am I correct? LMS access තියෙනවනේ? Yes,
ඔව් සර්.
okay. Yes, okay. Then I will upload some reading material. So if you want, you can read them further. As well as I think you have a quiz or the exam on this subject. So the diploma coordinator, course coordinator will inform you the date of the exam. Okay, then that's all. Next week also we will meet again because you have a part of the previous subject, field crops and export crops. So the export crops part we will learn next week. Okay, then thank you for joining today and have a good day.
Thank you, sir.
Thank you, sir.
Thank you, sir.